let's start. I'm Ravichandran, and it's a pleasure to welcome all of you to the Climate Studies Symposium as part of TechConnect 2025. I think we'll do something unusual and ask everybody here to introduce themselves to the team so everybody knows who everybody is. I've started, so I'm Ravichandran. Yes. No, I'm a member of the faculty at the Center for Climate Studies. I've been here 3 years. Before that, I was in Stockholm. I did my PhD. I'm a fluid analyst by training, and here I do a variety of other fun things. So I'll ask Pranay Shah to start.
Hello everyone, I am Pranay Shah. I take care of SME products at Tata IIT General Insurance. So I did my chemical engineering and MBA, and after that I was in Bharat Petroleum for a couple of years and then joined the insurance industry. So I've been in the insurance industry for about 23 years and so with a technical background. So the good part is I'm in commercial lines insurance, and it requires a mix of both the technical understanding as well as the finance understanding that I got through my management course. And I'm happy back here in an engineering institute sharing my views with all of you. Thank you.
Yeah. Hi, myself is Laxmikant Naik. Basically, I have done my MSc PhD in environmental sciences. Later on, I was in Naik, then to CVS, then to Tata Consultant Services. I was expert as a biodiversity expert in environmental sustainability health and safety department. And basically, we were doing for the implementation ISO 14001, OSHA 18001, energy management system, and previous to that, I was on road and highways project, particularly for World Bank projects. How biodiversity is protected during the construction of roads and all that. So that was very important thing. Now I am at Dahanu Taluka Environmental Protection Authority as a biodiversity expert because actually various development projects come from the environmental clearance. So during that time, this biodiversity also plays an important role. How industry is affecting biodiversity and what measures are to be undertaken for conservation of biodiversity. I think that is a very important aspect which I was doing since my last so many years. More than 35 years in this area because I was also part of environmental expert for the Tata group. So whatever industry takes any sort of things, there will be the impact on that. How we have to increase it. During TCS, we have taken a very good project of how individual land holdings, maybe 10 acres, 15 acres, 70 acres, 100 acres, can be developed as a biologically diversified landscape so as to prevent the climate change, how to mitigate the climate change impact because of this, and we got 3 international awards for this. Particularly ESG award was very important. What we have at TCS for biodiversity conservation, that was well taken by the international award. So international environmental best practice award also we received. More than 100 awards we received in the field of biodiversity. At present, it is very pleasure to come here and tell you about all these things. And any questions, most welcome. You can please.
Yeah. Good afternoon all. Myself, Somnath, Nandan. So I work in presently with the Kalpataru project international limited as head of engineering. So when I got this invitation, I was a bit surprised that what I need to speak or think about climate studies. Then when I look back to my experience, then I thought whatever we do, it has got a huge impact on the climate. And also to the civilization. So I have been working in this industry. I am bachelor's in civil and master's in geotech, and I have been working in this industry for more than 3 decades. To be precise, 32 years I have been working. And I worked on all the infrastructure areas, starting from airport. You have seen the bridge here, Mumbai Trans-Harbour Link, one of the packages. So I gave a presentation in IIT Bombay also a couple of years back. Then Noida International Airport, so many other things, water sector, industry. So what we see that we are changing the landscape of the earth, dealing with the earth science or climate, and that has got an impact to the society and to the environment. So it is I'm quite privileged to have come here and to listen to. Basically, whenever I come to this kind of institutes. I learned. So I have come, my personal thing is to learn from all of you and also interact. Thank you.
Hi, I'm Vishal Dixit. I'm a faculty at Center for Climate Studies. I will be giving a talk, so in the interest of time, maybe I will also talk then. So pass on to.
I'm Subimal from Civil Engineering as well as from Climate Studies, and I work in the area of water and climate. I am Jaideep Joshi, also a faculty in Climate Studies. I'm an engineer turned ecologist, and you will hear from me more during my talk.
Hi, good afternoon all. So, myself Rahul Baragar. I have done my Masters in Stats and Computing from BHU, and I am currently working at SCOR, Global Reinsurer. So I have come here to attend this event. So, thank you.
Shall we go out through the audience? Yes, you can start.
I'm Aniket Goalkar, and I was a postdoc at Center for Climate Studies on the Urban Fuel Project.
I'm a PhD student pursuing my PhD in Climate Studies Department, Policy Governance related to the Climate Studies. Thank you. My name is Siddhi Mahagaukar.
I'm Guri Bobhani. I'm studying in 11th. I've taken science, so I just wanted to see the seminar. I've come here to explore.
Yeah, I'm Khairunisa. I'm accompanying her so that she gets the exploration about various countries.
So this is Shivam, first year student at Center of Climate Studies and take one of the course of doing this climate assessment.
So I am Srijan. So I am also an engineer from BITS Pilani. I am working in Tata IIT under Pranay's team. I am a risk underwriter. So particularly over here we are exploring the avenues how climate change affects insurance. Per se it does not appear to be. However, while day-to-day activity involves a lot of commercial insurance, wherein climate change is a very significant part, which we'll see in further talk.
RA in Woodland Institute.
Yeah, I Sumriti, first year climate studies PhD, working on climate mitigation.
Hi, I'm Krishna Priya. I'm first year PhD student in Center of Climate Studies.
Hi, I'm Jay Shingle. I am MTech student in climate and sustainability in the Center of Climate Studies.
Good afternoon, everyone. I'm Nirul. I'm from Environmental Science and Engineering Department. I'm PhD scholar working on flood resilience. Thank you.
Hello everyone, myself Nandan Chakravarti. I'm a final year. I'm currently working on national scale flood risk forecast.
Good afternoon everyone, my name is Anirudh and I'm a project assistant at the Center for Climate Studies. I work on extreme precipitation events.
Hello everyone, I'm Kumar Mukul. I'm a joint PhD at IITB and Pranay University. I'm working on hydrogen for energy transition in India.
Hello everyone, my name is Gaurav Banjir and I am the final year PhD student at Climate Studies. My research topic is on drought assessment and prediction.
Hello everyone, I am Pooja Tripathi. I am final year PhD student at Center for Climate Studies and I am working on rainfall and drought forecasting for.
Hi everybody, my name is Arya Savi. I'm working as a project assistant at the Center for Climate Studies and my work concerns with downscape exploitation.
Hello everyone, I'm Jayan. I'm a third year PhD student and I work on storm.
Hello everyone, I'm Sakshi and I'm a PhD student at the Center for Climate Studies and I work on ozone cloud interaction, how it impacts the radiation budget as well as the precipitation.
Hi everyone, myself Madhulika Singh. I am second year PhD student at Center for Climate Studies. I work on agriculture water management.
Hi everyone, I'm Girivendra Pratap Yadav. I'm a second year PhD student in climate studies. I'm working on the topic of multiple impacts and benefits of sectoral energy transitions in India.
Hi everyone, I'm Sabirul Sheikh. I am PhD student here. My work is on quantifying the role of topography and geomorphology on flood occurrences using different statistical techniques and AI.
Hi, my name is Manoj. I'm part of Aditya Birdla's corporate R&D and my current focus is on new technology areas and decarbonization.
Good afternoon everyone, I am Kaustubh Mondal from
Environmental Science Department. Recently, I just completed my PhD in flood modeling, uncertainty analysis, and flood management. Thank you.
Good afternoon, everyone. I am Jaideep. I am right now I'm a PhD scholar of the Department of Center for Climate Studies. So I work on quantification of the impacts of cyclone, and particularly also with respect to the economics part of it and also the disaster risk financing.
Hello everyone, I am Shubhashish. Currently we are PhD student in here, and I am working on grade competition.
Hi everyone, I am Mohan. I am a PhD student here working on climate change impact on ground.
Hello everyone, I am Somnath. I am a PhD student here. I work on water vapor dynamics and moist convection during municipal.
Hi everyone, I am Sheila Rao, and I work with the organization called the insurance company, which is a insurance company, and I'm a part of catastrophic risk and investigation. So I'm part of PhD.
Hello everyone, my name is Kalpataru. I am second year PhD student under Professor Subimal. My topic is climate and weather service agriculture system.
Hello everyone, my name is Sheila. I am working in a project renewable energy forecasting, and my work is basically nowcasting of solar radiation, and the project is under Subimal.
Hello, myself Ajinkya. I am working in the last year of my PhD, and my topic is related with the land atmospheric interactions, particularly how the processes with the soil and vegetation influences atmospheric process.
Hello everyone, I am Dipan. I am PhD student from Center for Climate Studies. I am working on understanding the climate change impact on vegetation.
Hello everyone, good afternoon. I am Harsh from IITB. I have an overall experience of 5 years in planning and agriculture doing, and I am working with licensing team of and tech transferring of IITB. So if you are an industry partner want to collaborate with us, we are happy to license our technology.
Hello everyone, I am Srini. I am head of PMC for SCOR India. SCOR is a reinsurance company headquartered in Paris, and we are set up in India in KC.
So, good afternoon everyone. My name is Shubhankar Karmakar. I am from the Environmental Science and Engineering Department. That is my parent department. I am also an associate faculty in Center for Climate Studies. I have been working on the climate impact assessment, mainly focusing on flood management. Thank you.
Thanks everybody. Thanks for all being here. It's very nice to have all of you. I will ask Subimal, the head of climate studies, to tell you all about a brief overview of what the center does.
Thank you, thanks Ravi, and welcome you all to the special event by the Center for Climate Studies in the TechFest 2025 as a part of TechConnect, an initiative by IRCC, our Dean R&D's office, so that we can have interactions with industry partners on different works what exactly we are doing, and that will probably help us to develop collaborations between industry and academia. That's the purpose, and with that we are starting. So when I'm talking about climate studies, of course we are all aware of what exactly is happening. The global temperature is increasing, global warming is happening. We are almost very close to 1.5 degrees centigrade warming. Soon we will probably reach 2 degrees centigrade warming. And as a consequence, we are seeing increased extreme precipitation, increased drought, increased number of heat waves, and also that results into multiple other issues, problems, losses, life losses, economic losses, and so on and so forth. So one of the things which I'd like to mention, 13 years back in 2012. There are few faculty members from IIT Bombay who are from various different departments. Some of them are from civil engineering, some of them are from environmental science and engineering, some of them are from Center for Technology Development for Rural Areas, some of them for chemical engineering. So all of them came together, and we thought that we should have some kind of a center which can directly address the problems related to climate change. Remember, at that point of time, there were centers which are focusing on atmospheric and oceanic sciences. There were centers which are only social aspects. But there was no specific center which can really run a PhD program which is on climate change, which can cover the 3 areas of climate science, where we really need to understand how the climate works. So what are exactly are the different processes, how the monsoon, for example, how the monsoon system works, what are the processes that results into drought, what are the processes that results into heat waves and so on. Then comes climate adaptation. When you're talking about climate adaptation, what we are trying to say is carbon dioxide is a gas which stays in atmosphere for a very long time. So for example, if tomorrow you start emitting GHGs, let us assume a condition from tomorrow we stop emitting GHGs, there is absolutely no GHG, everything is green, then we think that all these problems will be solved. No, it will not be solved. The kind of carbon dioxide which is there in the atmosphere, that will result into significant increase in extremes or the ongoing occurrences of extremes at least for next 50 to 60 years, even more than that. And one of the sad part is that this kind of global warming that has happened, we were not really responsible for that. Our country was not really responsible for that. This was done by so-called developed countries, and we are now seeing the consequences. And at the same time, we are under British rule till 1947. After that, we started developing, and we had certain economic limitations, so we have less adaptive capacity in that sense. So we are facing the consequences in a very bad way. So the idea here is that can we really make us climate smart so that we can really handle this kind of problems, the consequences of climate change. So it is saying that we can say that how can we manage the unavoidables. For example, tomorrow we are stopping greenhouse gas emissions, but so there is something which is unavoidable, which is going to happen and which is happening. Can we really manage that? And that is known as adaptation. By what way? We can do it in terms of, let's say, coming up with a very good forecasting system. We can have a very good system which has a very good stormwater drainage management. We can have a very good agricultural system where we can manage drought in a much better way. So this falls under adaptation. Then third is climate mitigation. Climate mitigation means, for example, the way we are increasing GHGs. If we keep on increasing GHGs in the same way, then what will happen? We'll reach a condition which will be unmanageable. And when we have to avoiding the unmanageables, that is known as mitigation. Adaptation means managing unavoidables, and mitigation means avoiding the unmanageable scenarios. And we can do that by reducing greenhouse gas emissions, by going for more greener technologies. So we thought we should have a center which can take care of climate science, climate adaptation and climate mitigation together. Across interdisciplinary ways, essentially adopting interdisciplinary ways by involving people from different centers, different departments and so on. We started with that. We became Department of Science and Technology's first center of excellence, a PhD program on climate change. We continued for 2 phases. The first phase was led by Professor Chandra Venkatraman. The second phase was led by Professor Shubhankar Karmakar, who is sitting here. So, and then of course we started bringing other projects and so on. So that's the way we sustained. We sustained for over 13 years, and over these 13 years we have been changing ourselves so that we can really work with stakeholders, work with people to not to just focus on science, but taking science and really making it applied. So that sort of idea, because we are in an engineering institution, we have to think about science, but founded on science, can we really develop technologies? That's the idea. With that way we started. So if you look at it, one of our idea is that, of course, that is something which is being mentioned by Ministry of Earth Science as well, that we have to make ourselves weather ready and climate smart. By weather ready means we have to be ready for whatever extreme condition that is happening for tomorrow, day after, and so on. We have to be ready for that. And climate smart means our adaptation strategies will be such that we can adapt in a much better way. Plus, whatever technology we develop, this should have less GHG emission, it should have less carbon footprint. So we have to make ourselves weather ready and smart. And so what we work on different areas. We work on mitigation, we work on adaptation, we work on vulnerability risk, we work on adaptations, and then early warning system. And our idea here is that can we design very good climate services that will make our water sector, energy sector, infrastructure sector, air sector, food sector, agriculture, all of them weather ready and climate smart. That's the idea. And so when we are talking about really management and adaptation, we are talking about day-to-day management, what is very important. For example, we all are from Mumbai, and we know that if tomorrow there is an extreme rainfall forecast, we normally change our classes in schools to online classes. Right? That's one of the things is an example of day-to-day management. And for that, what is needed is very good early warning system. And the second one is, for example, let's say I'm starting a farming business, and I have to think, whether should we go for invest on grape or sugarcane or something else, or what exactly we need to do. So for that, we need to understand that for the next decade, what will be the scenario. And if we have to do that, we have to go for decadal scale predictions as well as multi-scale projections, based on which we can take policy decisions. So when we are talking about weather and climate, we are essentially talking about multiple scales, starting from weather to sub-seasonal to seasonal to decadal to multi-decadal. And we should have very good understanding of processes, because for different scale, different processes dominates and different decisions come out. So it's very important to understand these processes if we have to make ourselves weather ready and climate smart. And this is exactly which our center does. So our vision is that to become a world leader in research, education, innovation and capacity building in climate science and solutions for sustainable development to help protect human natural system. In this regard, one of the things what I would like to mention, I would like to focus mostly on the fact which is known as world leader. So just a couple of days back, I was talking to an eminent scientist from Smith Sciences, which is essentially a philanthropic organization by the former CEO Eric Smith. So he was telling that India is one of the country which is badly affected by climate change, for which probably they were not responsible, but now they have to develop. India is developing very fast, it's an emerging economy. And some of the greenhouse gas emissions are inevitable. So use of energy we have to do. So the idea here is that we need to have very good adaptation and we need to have very good mitigation strategies. And India is probably one of the country which can become a global leader and show the globe, show the entire world that this is the way we have to develop our adaptation, this is the way we have to develop mitigation, or in some sense adaptation will help in co-developing technologies for mitigations, or co-benefits will be mitigation, or for mitigation technologies the co-benefits will be adaptation. So that is a unique opportunity for India to become a global leader in this specific area, and that's why even their focus is on India. That's what he was telling, and it was something which we have been thinking, because last year we had some meeting what should be the mission and vision of our center. This is exactly we discussed, and then I told him that yes, this is exactly we are thinking. I'm very happy to hear that we are also thinking in that way. So there is an excellent opportunity for our country to become a global leader in this direction, and which is probably the most important area, which will be the most important area in coming decades. And our mission is that foster rigorous academic research in Earth system processes, adaptation and mitigations. And most importantly, we would like to co-design end-to-end solutions. We are not like that we'll generate the forecast and leave it there. So what we would like to do is that we would like to work with the stakeholders. We will not force anything on the stakeholders. For example, if you work with farmers, we will not say, look, these are the strategies you have to follow. We do not want that. We try to understand what farmers do. Then add a layer of weather forecast and tell them, look, if you add this component, your tool will look like this. Of course, you have to work with them, re-modify the tool and ask them, can you use that and check if it is helping you or not. So this is something which is our strategy. We do not want to force anything, but we want to work with people. For example, one of the Mumbai flood forecasting, we wanted to work with citizens and we developed crowdsourced information. And we are thinking with this crowdsourced information, can we improve our transportation resilience understanding? So that sort of thinking we are thinking. So we are thinking in that direction rather than just in a routine way of improving science and just releasing the forecast. It's not like that. So that is one of our vision or mission which makes us different from any other centers in this country as well as across the globe. So we have 4 verticals. Of course, education and outreach is one vertical, which is like any other center. The second one is research, of course. The third one is human research development. But I was saying that, of course, any academic division in IIT Bombay has these 3 verticals. The fourth one is very important. Here we are talking about co-design solutions, where we are working with the stakeholders and co-develop solution. For example, we are developing a tool for renewable energy forecast with Grid India, so that we can develop a complete tool that will take care of renewable energy forecast, and they can do the scheduling of energy sources, etc. And so we are working with them. So we can really co-develop, together develop with the knowledge we have related to climate change. That's something which we are working on. So co-design solution is something which that makes different from others. And as per our research area, we work on climate processes, we work on climate impacts and adaptation, we work on climate mitigation, and the fourth one, climate solution and policies. Now, as our long-term vision, one of the things which we have to understand is that the whole science and technology of climate is changing very fast. For example, we talk about machine learning, and we know how fast machine learning technologies are changing. In the same way, climate is also changing very fast, depending on human need, depending on societal need, even depending on the change in geopolitics. Depending on that, we have to change ourselves, right? Continuously change ourselves so that we can be weather smart, weather ready and climate smart. So, considering that, we also thought that we also have to change ourselves. For example, pre-2024, we are thinking more on research in science. We wanted to be a research organization. But after that, we realized that, of course, we have to contribute more in technology development. So we started MTech program in 2024. We are developing living labs so that we can work with the citizen. We are working with government bodies and stakeholders. But in 2030, looking ahead, what we are thinking is that, yes, of course, we have to develop MTech programs, many things we have to do, but we also have to do something in the space, innovation space, in the entrepreneurship space, so that we will not only we do think that of course our students need jobs in different industries and so on, but we also want our students will create jobs by starting new startups. So that's one of the idea we are thinking. They can be the leader of next decade's industry. So that is the vision we are looking ahead, and also we are going ahead with UG program. We are planning in what way we can start even a UG program. But of course, before that we have to develop entrepreneurship and startup ecosystem. And when it comes to 2047, of course, our target is net zero 2070. We are in that direction, so we have to think of very good mitigation. But we'll always focus on adaptation as well, because what is happening across the globe is that we are focusing too much on mitigation and forgetting adaptation, which our country needs. Our country's main priority is adaptation. How can we save people from increased number of extremes? And so, of course, we'll focus on mitigation, but at the same time, we'll make sure that adaptation is also our priority. So, and this is not easy, because when you're talking about different sectors, when you're talking about different areas, different verticals, it's not very easy. And for that purpose, we have 7 core faculty members and 29 faculty members across departments who are contributing to climate studies. Climate studies is not just a few core faculty members. It's 4 faculty members, but at the same time, associate faculty members from various different departments. You can see these are the different departments who are actively contributing to climate studies with different backgrounds of students. We never say that students have to be from atmospheric sciences. We never say that. We want students from different background. They come together, they work together, develop that ecosystem that will result into really a center that can think of science, that can think of mitigation, that can think of adaptation. Yeah, so as I said that our journey, we started in 2012 to 2016 as first center of excellence. Then we moved to the version 2 where we started stronger collaboration, and also we started representing on different external organizations. Then 2022 onwards we started thinking, we have started recruiting more faculty member, we started bringing fund, we have started working with the industries like NGSCRO, we are working on Oracle, we are developing living labs, we have started MTech curriculum, and also we are promoting climate entrepreneurship. In fact, within climate studies, we have started few awards for climate startups and entrepreneurship. One is, it was donated by some of our donors, Dr. Kapoor, Dr. Samir Kapoor. They have donated some fund, and with their contributions, we have started an award that will promote climate entrepreneurship. And if that they get succeeded, if the awarded team gets succeeded, they have the opportunity to go to sign and come up with startups. And this is actually happening in our center. So as I said that when we are talking about our foundation is climate science. So we do not believe in those technologies and those startups which talk about decarbonization, climate adaptation, climate mitigation without understanding science. Science should be foundation, and based on that we have to design adaptation and mitigation. And that is something which we proudly say that we do not think of anything which is not based on science. It has to be founded on science, and based on science we have to think of adaptation and mitigation, which will give you the holistic view of climate and sustainability. And of course, as we said that we should have translational potential, and we are developing different tools related to science and adaptation. And these are actually different areas. So for example, when we are talking about climate adaptation, managing the unavoidables, we are talking about early warning disasters, droughts, flood, poor air quality condition. For example, all of us are talking in this room, and over the last few days, the Mumbai air pollution was really bad, air quality was really bad. And everyone was actually looking at mobile, right? How long this air quality episodes will last, so that we'll then stop coughing. And this is what that is very important. Early warning system is very important. And same thing happens when extreme rainfall happens. We ask, when we'll see the sunshine? How long this extreme rainfall will happen? So early warning is very important, and this is extremely important over the coastal region when there are forecasts of cyclones or heat waves and so on. Then this is early warning. This is also another very important thing. Still now we are not doing very well even with dengue forecasting system. Bangladesh has a very good dengue forecasting system, but our country we do not have based on time. And one of the bottlenecks is of course data and other things, but the important part is that we have to develop these things. Renewable energy forecasting, there is a need, and in fact the Secretary of Ministry of Power visited IIT Bombay. They have asked us to develop renewable energy forecasting tool for their system. This is becoming very important. Agriculture, whether smart agricultural decision, crop planning, we have been working with farmers. There are startups which came out from our center who are working on this. We are working on water resource management, urban-rural conflicts, and we are also working on climate risk map, hazard and vulnerability. But I'd like to mention when you're talking about climate risk, bringing hazard, vulnerability and exposure, all of them together under a single framework, which was suggested by IPCC, but it was not used in this country. The first entire country risk map was developed by Professor Kalpataru. So these are some of the things which are being done, which are very unique, and I'm really proud of my colleagues and students who have really contributed and makes us really different from others. And then climate mitigation, when we are talking about how can you think of, we have colleagues who are developing new greener technologies like green hydrogen, and they have their startups. We have CCUS, we have a specific center on CCUS. We are contributing to clean environment policy, energy management, life cycle assessment and so on. So we are working on different aspects of climate. And as I said, that the idea here is that we think of this kind of structure where we think first we should have a very good monitoring. You cannot monitor everything with sensors. We have to bring citizen sites, we have to crowdsource, we have to use models, and you have to bring every information. We have to start with small community, develop digital twin, and then upscale. And then we develop adaptation. We design adaptation, but should not forget about mitigation. Design mitigation, but should not adaptation. So there should be co-benefits between them. So that is sort of the idea of climate studies, and these are essentially ongoing projects. I am not going into details. Just would like to say that we have been working over the last 13 years, and we hope that our students, our faculty will continue, and in the upcoming decades they will collaborate strongly with industry with a vision that our country will be weather ready and climate smart. Thank you.
Thank you very much. Unless there are any questions for
just one question. You mentioned about the prediction of diseases.
Yeah.
Is it limited to only communicable diseases?
Yes, mostly communicable and essentially vector-borne diseases. This is what we are thinking. And also we can think of disease which are resulted from air quality.
Yeah.
That's also another thing. Yeah. Yes.
If not, let's thank Subimal again, and I'll ask Vishal to talk about climate extremes and risk assessment.
Sure, yeah. I might need whiteboard for the part.
So we'll see how these can be lifted up.
Yeah, by the time my colleagues figure out a way to reach the whiteboard, kind of let me ask you, when you see this picture which is AI generated, what do you think of? And you are free to say whatever you like, including students and all the guests.
I met with this camel with cycling inside.
Okay, yeah, that's a good start. Anyone else?
Yeah, extreme. So one side you see drought and one side you see flood.
There is a contrast. Yes. Yes, I think contrast. He was also probably saying that camel will go in the tornado.
Solution is renewable energy.
There was renewable energy. Yes, there is renewable energy. Some solutions. Yes. What else?
Urbanization. Talking about also urbanization.
Urbanization. Yes. There are just too many things in this.
Too many things are there actually.
Yes.
Also big risk now.
Yes, yes. So on one hand, I put this figure, and the prompt I had given was what one image can depict multi-scale, multi-hazard nature of climate change, and this is what it popped up. So multi-scale is the keyword Subimal mentioned about. The other thing I feel is multi-scale, also meaning deserts or coastal regions and so on. But the other important thing is, which is kind of, is a bit of a social science type thing. And I'm not a social science scientist myself, but I find it quite fascinating. And that's that actually many a times you would see doomsday picture being painted for climate change. And one thing at our center we are trying to do is risks. When you try to understand it better, you do not kind of, there's no point in just painting a doomsday picture, but instead designing solutions. We are at IIT, so how to really inform adaptation and mitigation, as Subimal said. Okay, now we have the whiteboard. It will be required for a middle piece, 4 or 5 minutes. Ravi, please be the timekeeper and shout at me in case I speak a bit longer. I would like to start with this. This slide and ask you, how do scientists, technologists should see climate? They should see climate as a distribution of weather states. So let's pick one variable, let's say temperature, and on y-axis you plot frequency of occurrences, on x-axis the temperature value itself. And then you get some distribution, which you would like to call probability distribution. And there would be some properties which describe this distribution. Each of these temperatures is a weather state. Weather forecast problem would be to get these temperature states right in temporal sequence. But the climate problem is to get the right distributions. And the climate change problem would then be to get the change in this distribution. And you can already see that as we go near the tail of the distribution, the number of samples are less. So our ability to also inform about what will happen to the tail of distribution will be difficult. And with climate change, this figure is taken from IPCC. What we know is, for a given weather state, it is very likely that the same temperature will occur more probably. So the probability will increase, or the same probability but at hotter temperature. So these
So in some ways, this is one very simple way of describing what will happen to temperature. And technically, you could do this for many climate variables. Let's look at what IPCC did to describe this. So they made this very fascinating chart, and I like showing this especially to people from the industry, because I feel with the new climate risk disclosure requirements, every industry would want to have such a table just for their own industry. So on x-axis, there is climate impact driver, either heat or cold, and then there is a bit of a detailing: frost, cold, extreme heat, and so on. There is wet and dry related to precipitation, and then there is a larger variety related to variety of climates across Asia. This map is made only for Asia. Then there is wind gusts, renewable energy or infrastructure, lot of implications there. Snow and ice, for example, hail is a problem for orchardists. I am not kind of taking every, permafrost is a big problem on a decadal and longer time scale. Coastal and oceanic and other drivers. For example, atmospheric CO2 at surface is increasing, radiation at surface is increasing. On y-axis, you have different regions. Let's just focus on our country, SAS, which is here. And the colors show the amount of confidence you have. The bluer the box, the higher the confidence. And then there's a bit more detailing about if it has already emerged or it is projected to emerge. And what you can see is heat and cold related stuff is, there is high confidence. We know rainfall is going to be important, but there is hardly any confidence about the change in rainfall. So we know all of this matters, but we are able to say about certain variables with some confidence. For example, coastal and oceanic, we have a couple of variables where we have high confidence. My point being, we will want to think of all of them for every grid box in our SAS with high confidence. That's the sort of information we would like to have ultimately. Let's look at the next version of this. If we look at sector-wise climate risk, then again the same x-axis is plotted, and on y-axis you will see different sectors kind of mapped onto each of these climate impact drivers. You have food, fiber, ecosystem. My colleague Jaideep will talk a little bit more on this. Cities, settlements, Subimal mentioned about his ongoing project on Mumbai, flood management and infrastructure. Health, Subimal mentioned. And each of these boxes, again, is about confidence. So, if you pick a particular industry and ask the question, how much of risk does it pose to my industry, then you would want all of these boxes to be dark brown. That means you have great amount of information with great confidence for all of these sectors because of all of these climate drivers. But as you can see, this is unfortunately not the case right now. Okay, how do we understand climate change right now? This is again taken from IPCC, and here I am trying to show you how much would the mean change across seasons. How much would the mean change? So Subimal mentioned 1.5 degree by and large. How would the extremes change? That's shown here in the right. For example, mean versus extreme. If you were to just believe this information that is produced by climate models, you would feel that everywhere across in India, you would go from light orange to darker orange, which probably means 2 degrees to 4 degrees. And what 2 degrees means for your business or for our society is very different than what 4 degrees mean ultimately for our society. So that means these climate models are great in terms of telling you in which direction our climate is being pushed, how is the probability distribution changing, but they unfortunately do not have sector-specific knowledge. What would happen in Mumbai, or what would happen to your businesses in different locations, or what would happen to states that you care for, how to prepare for that. Unfortunately, we don't have a good resolution information. That's what I wanted to say. And especially good resolution information for extremes which matter. And with this, I would like to pause and go to the whiteboard and tell you why is this a hard problem. So let's pick a location. Let's pick Mumbai. I like Mumbai, so or you pick your own location. And I want to mainly highlight the point that it is a multi-scale thing. That's what I want to do. Multi-scale is the keyword. So the way extreme rainfall events happen, it's essentially, if you were to put that in a nutshell, it is mainly 2 or 3 things. And these 2 or 3 things are very easy to articulate, but very difficult to diagnose and mathematically model. So I will do the first one. I'll just tell you what are these 2-3 things, and I will kind of challenge the students to really model that. That's what we do at IIT. So let's say there is one location, let's say Mumbai, with some high-rise and some low-rise buildings with, say, ocean next to it. And the question is, on Mumbai, what would happen? Clearly, this map will tell you it will go from lesser shade of orange to darker shade of orange. I am also going to write one mathematical equation on top, which is rain-making process. This omega times partial derivative of specific humidity. So this is precipitation. This is humidity. I am not going to write specific. This is not a thermodynamics class. This is vertical motion. Yeah, vertical motion. So to make precipitation a particular intensity, you either need lot of vertical motion, or you need humidity to change with height. Z is height at a very high rate. You need either very high ascent in the sense vertical motion, or you need very strong gradients meaning change with height. Now you can ask me, so P extreme will be because of this product being extreme, and what will change with climate change? The interesting answer is that humidity will change, vertical velocity will also change, and we know that this happens. All these models that we use usually model this, but do not model it at the level at which it matters. So how much W at your site or how much W at your location will happen. This is also controlled by flow that occurs over, say, infrastructure, or if you live near orography meaning mountains, or if you live on the borders of desert and semi-arid regions, at what rate would ascent happen, and at what rate would humidity change as temperature changes? This is the crux of the problem, and we don't have information at a fine scale. Okay, so if the heat wave problem, is also not very different, but I will probably, in the Ravi says 5 minutes, I am going to pause myself. It's essentially saying, how will vertical motion ventilate out heat? Let's say there was a heat dome, there was a heat dome here with lot of temperature, positive temperature. How will vertical motion ventilate out this heat? If heat is carried away up in the atmosphere or washed away over ocean, heat wave is not a problem. So it's essentially tied to similar logic. This is what I wanted to tell you. Okay, so I have my last 3 minutes. Okay, so I want to talk about 2 examples. One example is where some of us think that if you were to make a bhelpuri of traditional weather forecast models, some physics-based understanding and machine learning, if you were to carefully mix them in the right proportion, you could potentially get what matters here. Yeah, that's one line message that we are trying to do. The motivation is that across India you don't get the most extreme rainfall events, and some universities are kind of collaborating together where we say, can we actually, even if we cannot write explicit mathematical equations for say W or Q, can we at least write down distributions of them and sample from those distributions? How will we create these distributions? And we are saying, let's throw ML at it. How will you generate data? We are saying we have computer infrastructure to do very high resolution simulations which are consistent in physics. Let's generate a good amount of data for W and Q and let's see what happens. So this is one example I wanted to give you. The advantage here is unlike the traditional models which are these climate models, machine learning models are quite, they are scale agnostic. So you could ask a machine learning model, I know this information at 200 km, respect these physical constraints and give me information that I care for. That is my whatever, 1 square meter, 10 square meters and so on. And will it do a fantastic job? Will it give you a deterministic answer? Maybe not, but it could give you a good probabilistic answer which you could use in your design curves or you could use in designing the strategy. I'm sure a couple of other examples are coming when Ravi speaks and Jaideep speaks later on. Okay, the other example I wanted to give you is work by Professor Shubhankar that Subimal mentioned. It's on risk. And Shubhankar keeps on mentioning, think of risk as hazard, vulnerability and exposure. And with latest IPCC also response is included. So instead of triplet, think of quadruplet. The work they did at Mithi River, I did not highlight, we all know how Mithi River is fundamentally important for Mumbai. What they started with was an integrated urban flood vulnerability and risk mapping. They used kind of 4-stage modeling approach. They used high spatiotemporal, they try to resolve the rainfall vulnerability. They said that the abrupt change in slope really matters in a catchment. So let's get a good representation of slope. There is another challenge of unplanned settlements. This is beyond design control, but having knowledge of that is going to be fundamentally important. And they also said, why not tie it to the tidal model? And they made risk maps for socio-economic infrastructure or adaptive capacity related vulnerabilities. Shubhankar is around. I will request Shubhankar to explain this in great detail. I am kind of doing a replacement job in some sense when the original author is here. They also they then asked what if scenarios. If the rainfall were to happen for 1 hour versus 6 hour kind of design rainfall, they asked, this is a map of Mumbai, how would Mumbai flood? So they generated scenarios and this was done for 2 events, 2001 and 2011. So you could kind of do this then bivariate flood risk map. On x-axis you could think of vulnerability, y-axis hazard, and for each pixel you could ask how vulnerable and simultaneously facing hazard is that location. In the interest of time, maybe I will not describe this slide in great detail, but leave you again with this particular slide where I want you all to think about how can you produce, especially to guests, and how can you produce such a map for your own industry, because this is going to be of fundamental importance when you really report risk to your business or for governments to really report how is your industry influenced by climate change, or how are you influencing kind of climate through influencing any of these factors. I think with that I will stop. Sorry.
Questions for Vishal?
Yes.
I really want to understand the resolution of the data you are able to capture in this map.
Yes.
What is the spatial and vertical resolution?
So I think ongoing, what we have right now is, I think what I criticized as well, is what I actually worked on for a long time. For example, this type of resolution is around 50 kilometer resolution. And but what's possible with high resolution modeling is around a kilometer. But if you use also ML and try to really extract stuff, you could go to farm scale. That's what I think one of the project that one of the later person will highlight. So farm scale meaning few hundred meters, few tens of meters.
Anybody else?
Yeah, just one question on this particular equation. The equation what you have presented there. One of the things is the vertical element and then and especially in the urban situation, high rises is something that comes up every now and then. Now the whole model is getting kind of disturbed in one way or the other. How it is kind of taken care of?
You mean that currently one grid resolves all of the high-rise, low-rise, everything?
Yeah. So,
yes.
Yeah. For example, so when for example the model which he had prepared, I believe it is from 2001.
Yes.
And now it is 2025. Now
yes.
There would have been a big, and especially on the flood part.
Yes.
Where all these things.
For his model, he uses DEM at a meter resolution. Few meters of resolution. So please.
Sorry. So actually 2001 and 11, because of the vulnerability component, it's a risk map, typical risk map, where one important component was vulnerability. We focused mainly on socio-economic and infrastructure vulnerability. But in census data is available decadal census data. So for 2001 it is 2011. But the hazard part, which is basically derived from the velocity and the depth of flood, that is basically the latest data set. So, and also, I mean, last, like more than 30 years of data set. From there, we have derived like 50-year return level, 100-year return level, or maybe more frequently offering like 10-year return level flood. But at the same time, 1 hour, 6 hours. So 1 hour, 6 hours, these are called the nuisance flood. That means very short rainfall, but maybe intense rainfall may take place. And interestingly, for this 1 hour, 6 hour, these short, like rainfall spell is, mostly different for our Mumbai city. If you compare with other cities, mainly like fully urbanized or, like the urbanizing area, you will find out the difference. So that's why we usually prefer to show this, basically short, like the rainfall duration index.
And so, in Mumbai, we also kind of connected with the tide, high tide.
High tide. So here also high tide means when we are considering the flood modeling, we have considered the tidal impact as well. So it is a 1D, 2D model where the tidal influence for Mithi river, if you see, it is around 7 km from Mahip Creek region. So the effect, whereas the river length is 17.3 km. So that also aspect is considered. This type of modeling is very sensitive. If you change the rainfall data, again you have to calculate this kind of problem.
Yeah.
Other questions? Right, if there are no other questions, let's thank you. We'll ask Jaideep to talk about climate resilient agriculture and terrestrial ecosystems. Is that right? Are you doing that?
Good afternoon, everybody. So, I'm Jaideep. I will be talking about climate resilient agriculture as well as terrestrial ecosystems. And this is a presentation that will cover research done by both some part by me and some part by Professor Subimal. If you want to have a closer look at my group website, please feel free to scan the QR code. So when we talk about agriculture and terrestrial ecosystems, these are not really two separate things. If we look at the overall landscape, we will typically find a mosaic of agriculture, cropland, rivers, and so on, right? So most landscapes typically are, especially in India where human habitation is almost everywhere, including deep inside forests, we find some mosaic like that. And this is a strongly coupled human natural system, as we call it. And it has a lot of feedback. So all the processes that are going on in agriculture, in the forest, are deeply intertwined with what humans do and what the forest is doing, right? So humans rely a lot on the forests for ecosystem services. These are food products. So these are basically water for food production, agriculture, and so on. Soil retention, carbon sequestration, and then associated with that, we can ask a lot of research questions as well as translational questions. So what is going to be the amount of forest carbon sequestration? How much is the water conservation activities that we can do? Or how much is irrigation water use? How can we optimize it? Right? Can we provide some agro advisories so that we can make agriculture weather smart, climate resilient, and so on? And how can we perform forest restoration? So with climate change, a lot of mitigation actions are going to focus on the forest sector. And that's why forest restoration, reforestation is now in focus. And we want to make sure that we make the right choices when we do restoration. So in general, to tackle a problem of this complexity, we also need to look at multiple scales. Starting from, let's say, asking questions about individual plants and individuals or also human behavior. We ask how do individual organisms, including humans, respond and adapt to climate change? What kind of decisions do they make? How do they behave, or how do they adapt to climate change? Then we have to also look at the system. So because there are so many interconnections, because there are so many interacting components, humans affect forests, forests in turn provide for humans, and so on. So we need to look at the system as a whole. And this comes under something called system dynamics. So there we ask what are the emergent phenomena in such complex systems arising from these individual local actions. And finally, when we talk about solutions, we say, okay, we understand the science, now we want to translate that understanding into some action items. We want to make sure that we co-design, as Professor Subimal also mentioned, that we want to be able to work with stakeholders who are actually affected by climate change and co-design these solutions so that they also have more acceptability and also actually address the problems that the people have. So when we talk about weather smart agricultural system, it has several aspects to it. So we start with hyperlocal weather forecasting services. Unless you know what the weather is going to be like in the next season, for the next 2 weeks and so on, it is very hard to make these decisions, right? Right now, probably farmers are looking to the sky and then assessing weather qualitatively and making decisions. So we want to be able to make sure that we are able to provide farmers with accurate forecasts over multiple time scales, over from 1 week, 2 weeks to sub-season, season, and so on. Next key element is water, right? So farmlands need water, and a lot of agriculture in India is rainfed, and wherever irrigation is also available, Professor Subimal always makes this point, that irrigation usually should be applied when the crops need water, right? But when do you think irrigation is applied in most places in India? When water is available. When electricity is available. So then we need water conservation practices so that we can make good choices and good control for irrigation. Finally, a lot of agricultural yield and suitability or resilience to climate change also depends on the crop choice. So if an area is going to face drought in the future and then we are planting a lot of water demanding crops, then those are not going to be resilient when the climate changes. So what are the best suited crops for agriculture? That is something we can also inform based on science. So we can look at ecophysiology of different crops. We can see what are the crops that are resistant to water, those are less water demand, or higher water use efficiency, and we can make those choices intelligently. Finally, we can also perform intelligent irrigation scheduling, which means that, like I said, instead of applying water when electricity is available or when water is available, or just randomly flooding the land with water whenever it does become available, we can actually measure how much water is there in the soil, how much is the forecasted requirement of water over the next 2 weeks or so, and then based on that, schedule how much irrigation you have. So these are all components of what we call a weather smart agriculture system. So some studies that have been performed by Professor Subimal and his students have actually shown that there can be substantial water savings if we do intelligent irrigation scheduling. So in this study, they took the weather forecast from 3 to 7 days for irrigation water application, and also for the next 2 to 4 weeks in order to make suitable arrangements. And then also did seasonal predictions for identifying suitable crops. And overall, this led to 20 to 30% of water savings in this study. So this study has now also been published, and a patent has been granted for this system. now the question arises, okay, this is a very good case study. This is a perfect demonstration, but we always want to scale up and not limit ourselves to demos, right? So in order to scale up, we need measurements at a larger scale. And one of the challenges is that if you want to install sensors or a network of sensors, that is certainly the best option, but it might not be possible at the scales that we want. So then we have to somehow resort to remote sensing data or other means of acquiring data, like crowdsourcing, for example. So here then we can have pilot sort of living labs where we perform these measurements with IoT sensors or manually, and then calibrate satellite data sets based on these measurements. So this allows us to go at a much larger scale. So we can optimize irrigation decisions using weather forecasts, satellite data, models, and so on. So what we anticipate from this is like a ready to go strategy for irrigation scheduling, perhaps with very minimal data requirements, mostly sourced from satellites and maybe to some extent crowdsourced or measured in situ. So based on this system now, a startup is also being incubated inside IIT. So this is called Jaideep Climate Service. And what the startup aims to do is that they take the inputs for crops like crop types, crop properties, irrigation schedules, and so on. And then they feed that, they digitalize all of that, and they feed that to a hydrological model. So this hydrological model, along with a model of crop yield and so on, will give you what is the projected water requirement as well as projected yield. And based on that, they provide an advisory to the farmers for irrigation scheduling as well as crop tests. One key aspect of all of this is soil moisture, right? Water ultimately holds the soil, and soil is what supplies water to the crops. But soil moisture is notoriously difficult to predict. So one of the key areas of research is how do you downscale or get hyper-local soil moisture forecasts. So this requires certainly a network of sensors to be installed, and there is research grade sensors are typically quite expensive, but then there are also in the market already some low cost soil moisture sensors. So the idea is to use research grade sensors to calibrate larger networks of smaller, cheaper sensors and try to get a grid of soil moisture monitoring stations. Finally, hydrological models do not currently incorporate human impacts. So you can try to predict soil moisture, but then what happens is that it's not all natural. So there are irrigation, for example, will change how soil moisture looks like in a given farm. So in just a small area in this district, if you look at 4 different soil moisture stations, which are no more than 10 to 20 meters apart, you see very sharp differences in how the soil moisture profile looks like. And that is because of human interventions. So the idea here is also that can we model human behavior itself? Can we take into account these irrigation decisions of farmers, feed them into the models so as to get better forecasts of soil moisture? So that was all about the agricultural part. Now I'll talk a little bit about the terrestrial ecosystems part. Here we are talking about 2 main things, water and carbon. So when we look at forests or generally vegetated area across the globe, the photosynthesis done by the leaves of these trees or vegetation contributes to about 56% of the global carbon cycle, meaning the entire amount of carbon that is cycling the global carbon cycle, 56% comes from the forests. And out of this, a large amount, 123 gigatons, is uptaken by the plants as through photosynthesis. But most of it goes back into the atmosphere as respiration. But the net that remains is what we call carbon sink. So that is the biomass of the trees and the forests that you see standing. And this is what has been increasing because of climate change for a while. But now there are signs that this is decreasing again, and there is a sharp risk that forests will become carbon sinks, carbon sources, which means that instead of taking up carbon, they will start emitting carbon. Likewise with water, 30% of the global water cycle is actually driven by forests. And with increasing climate change, with increasing rainfall, this carbon, this water cycle and the contribution of forests to the water cycle is also going to change. So when we look at either crops or forests, there is one key principle that underlies the carbon uptake processes in both. And this is a dilemma that a leaf faces. So if you look at what happens when photosynthesis takes place, is that the leaves have the little pores on their surface, and these pores are where carbon goes in from. But these pores are also where water goes out. Now if you think about it, the carbon in means water out. But carbon gain is a revenue. If you think of carbon as a currency, then carbon gain is a revenue because that is food for the plant. But water loss is a risk, because if there is too much water loss, then there is a risk that the plant will die. So that's a cost. So there is always a dilemma. Should I open the gate or pore to a large extent and get in more carbon at the risk of losing water? Or do I keep it low to prevent these risks, but also lose out on food? Right? And this dilemma can be actually captured in mathematical equations through an optimization approach. And this presents a very, very powerful principle for us to model both the functioning of forests as well as the functioning of crops. Just to, I'll not spend too much time here, but there are a bunch of different modeling approaches that people use. Sometimes you can go as simple as saying that, okay, carbon uptake is simply proportional to the light available. It's a very, very simple principle, but pretty powerful. The next step is that you can say, okay, it's not just light, but it's temperature, vapor pressure, light, many other factors, and you can build a statistical model. Or you can build an optimality model, what I just described. You see, you actually put yourself in the shoes of the plant, you think about what the plant is doing, you put that in a mathematical equation, and that gives you the optimality model. So just to show you here some result of how well the optimality model performs when we compare predictions with data. And that gives us some confidence that both in predicting agricultural yields as well as forest performance, this kind of a simple principle can go a long way. Then what do we do with this model, right? Once we know how much carbon the leaf is going to take, we want to scale that up into the forest level productivity, turnover, respiration, and so on. And then finally, we want to predict how much is the amount of carbon that is getting sequestered into the forest. Why is all this important? Because when we talk about climate change mitigation, a lot of the mitigation actions are related to increasing forest cover and therefore increasing the carbon that is residing in those forests. If you look at the Paris Agreement that was signed in 2015, and if you look at the contributions that countries have pledged, 25% of it comes from the forest sector. So again, this model we have developed to some extent, and we applied it in the Amazon, and you can see that it predicts properties of the Amazon forest very well across multiple variables. Finally, we can also use these principles or strategies of plants to inform afforestation or reforestation strategies. So here you see 3 different species which have different times at which they peak their photosynthetic activity during the day. So looking at these species, can you tell me which one would be the best for restoration of a degraded forest?
Usually broadleaf trees are
these are all broadleaf, these are all evergreens. The only difference is when they are most active during the day. Right. So the best strategy would be that you plant a mix, right? Because then you have some plants active throughout the day. Yes. Big question. Yes.
Avoid monoculture.
Avoid monoculture, exactly. So that is also the importance of diversity when we talk about forest performance, productivity, and why diversity becomes so important. These are the little things underlying it. Finally, I'll just end with this slide. So what we want to do eventually is to take a holistic view of human natural systems and look at their sustainability and resilience. So we have climate change and management as drivers that create novel environments in which these systems are going to operate. And then we have the response of these systems to these external forcings, which then give us a lot of different ecosystem services, and those are going to change in the scenario. But then I also said right in the first slide that we are talking about co-design, right? And that is because not everybody are going to value the same services the same way. So governments might value carbon sequestration, farmers might value water availability for crops, industry might value timber, and so on, right? So everybody every different kind of stakeholder has different preferences for what kind of services they use for these systems. So we want to make sure that all of those preferences are taken into account, and we want to try to find, let's say, operating spaces for these ecosystems which maximize, let's say, the utility of all of them, or at least the most vulnerable of them. Thank you very much.
Questions for Jaideep?
Some suggestion for you.
Yes, please.
Yeah, because this is where Taluka information lab, and there are working for farmers. When they have developed a big system, weather monitoring system, and they have given even all expert committee was there on that. Anytime farmers want to ask any question, so mobile it was connected to the mobile, it was to expert, and immediately they give a solution. So some sort of very good system which is very available also. So actually please connect with them, and perhaps your efforts will also minimize. So how that can be done? That is very good and very effective. Even most farmers they have put it, but even particular diseases, what disease, what I got. So immediately they get expert advice and what has to be done. So that sort of work is very excellently done by them. So please connect with innovation and ICX, and they have done very beautiful work on this, particularly farmer community. And this is fantastic. I mean, perhaps it will be useful to you.
Yes, definitely. Thank you for the suggestion. Anybody else?
Actually, my thanks to everybody for keeping to time. It's gone very smoothly. So the next talk is by me. Let's see if I can find it. I will rush through. Only work in presentation. Okay. Sorry. It had to happen sometime. Tech trouble had to happen sometime. How do I open with Acrobat? That is the text. Thank you. Thanks to the Windows users. I'm Ravichandran. I've been talking here all afternoon. Most of the work I'm going to do, I'm going to talk about climate resilient urban infrastructure. A lot of work is done at the Center for Climate Studies on making an urban infrastructure climate resilient. Most of the work I'm going to do was done by several of these people. My part is very small in this whole thing. I'm just here to present the work my colleagues. I'm going to talk about two things. One of which is a project that's just about starting. Most of what I'm going to talk about is the Mumbai flood app, which is a project that came out of the center to use a combination of physics and machine learning to predict extreme rainfall and the consequent flooding at a ward scale in Mumbai. Using a variety of innovative approaches. So you need data. How do you get data? You can ask. You can get the citizens involved in generating data. That's one of the things that this project did. This is the team. You will not see my face up there, but this is the team involved with the Mumbai flood, responsible for the Mumbai flood. Lots of these people, including the students, are still here. I think Peter's here, Aniket is here, Ganesh is here. So led by Subimal and they were able to do this. I'm rushing through. They were able to do this. They've been at it for a while, and last year they it really worked. They got most of the extremes right, as we'll see in a minute. As I was saying, it's a combination of machine learning and physics-based models for rain. The problem with extreme rainfall events is that the large-scale models, the global models, the models with hundreds of kilometers of resolution, they're able to get the means right, but not quite the extremes. And it's the extremes that really kill you. If you're a city, for better or worse, most of us live in a city. It's 10 mm of rain is no problem, but it's if you want to predict flooding, it's the extreme event that you want to get right. It's the black swan that you want to get right. And getting the extremes right is a problem even in dynamical models. And so the idea was, can we use a combination of dynamical, by dynamical model I mean the kind of equation that Vishal wrote. You have a current state, you have an equation that tells you what the state will be tomorrow if you have the state today. And you start from an initial condition, you integrate forward in time. So machine learning model is much simplex pattern recognition of some more complicated than that, but let's think of it as pattern recognition. So I will not go through, if for no other reason than that I cannot, I will not go through all the details in this diagram flow chart, but it's a combination of dynamical simulations and machine learning model. So this builds on earlier efforts led by Subimal to predict flood in Chennai. And the problem with Mumbai is much harder because, and Subimal can please correct me if I've said something silly, it's much harder because the spatial variations are a lot worse. Some of us have colleagues who got caught in this event that I'm showing on screen. 2005, Mumbai got, in one day, got a meter of rain. But not all parts of Mumbai got a meter of rain. Santa Cruz got a meter of rain. Colaba, which is less than 20 kilometers away, got 83 mm of rain. 83 mm of rain is a lot in Paris or somewhere else. But in Mumbai, it's a drizzle. 83 mm is a drizzle. So Colaba got a drizzle, but Santa Cruz was drowning. So this is the problem in Mumbai. And this is what this project was trying to get right. Again, it's a combination of dynamical and statistical modeling. I will not go through all the details. And they're able to show that even when dynamical systems alone or neural net alone cannot get the extremes right, the combination will get the extremes right. And you will all know this. It's very easy to predict, to catch every miscreant if you think of everybody as a miscreant. So it's also important to get the false alarm rate. So we're able to show that even the false alarm rate can be improved by using this combination of dynamical and statistical. This is saying the same thing, so I'll skip this. The cool parts of this, they were able to float a Twitter app, a poll on Twitter or an app through which people in Mumbai can report where they are and how much flooding is happening at a given moment, how much rain is happening at a given moment. And they found a way to integrate that information into their modeling approach. Again, please Subimal, correct me, but I think this is one of the first projects to do this successfully. And they have, all good scientific efforts need validation. So they have sensors at various locations to make sure that what their model is outputting is actually matching reality. So like I said, they've been at this for a while. This is an event from July 2022. This shows you, that's an elevation model from Mumbai, and then this shows you where they got crowdsourced data from for flood levels. And they also got data from tweets, and they were able to combine all of this and use it with the automatic weather station data to make the forecasts, the predictions. So this became really good last year. So this is SWOT is where we are. Where does it say SWOT? SWOT is where we are. SWOT is where IIT Bombay is. Hawaii and so forth are all SWOT. This is across the June, July, August, September of last year, 2024. You can see, not every peak, you will not match every peak, but you can see how well the overall performance of the model matches the rainfall actually seen in. This is a weather station in the BMC office, in the SWOT office in BMC. So they're able to get the rainfall right, even the extremes right. You want to, it's Mumbai, so think of that as the extreme. So even 100 mm per day, even that, events crossing that, they're able to get right. This was last year, so this year they're able to, this is just telling you all the things I told you just now, the combining crowdsourced data and monitoring with cleverly used machine learning approach, you can get the rainfall right. This year they've gone further. Two things. One, we now have access to the weather radar from IIT Bombay, so we can do nowcasts. Nowcasts are in the next 2 hours what will happen. So again, it's built on a machine learning framework. You get the weather data, radar data from IIT Bombay, and then they can make 2-hour forecasts of where will it rain, how much will it rain, and they're able to show that it gets rainfall really right. The other thing is, if you know where in your city, ward by ward, is it going to rain really heavily, you can then plug that information into a flood model and predict where in the city will it flood in the next 2 hours, in the next 6 hours. This is important for all kinds of things, transportation being the most obvious one. So this year they got the flood model really working, and it gave good predictions. So I don't know if everybody remembers, but 18-19 August was more than 200 mm rain day, and their forecasts, 3-day advanced forecasts are on the left. These observations are on the right, and you will not see exact color match, but you will see more or less that the model got it right. And is there a flood? This is a movie, but it's a PDF, so it will not play. They were also able to, for the same days, they were also able to get the flood forecasts right. And like Subimal was mentioning in his intro, the BMC and other government organizations are using this. In addition to people who you can just log into the website and see this for yourself, but also the BMC is using this. And it's got lots of press coverage. It's a really useful tool, so it's got lots of press coverage. So Monsoon 2025 was the second successful run of this entire approach. Transportation, this is people putting in information which is being used to help people decide or learn where is it going to get really bad flooding. It's from the people to the people. So the other thing I wanted to very briefly mention is, I'm keeping time, is future work. This has to do with, we're calling it urban extremes, but it has to do with cities are known to be heat islands. So the temperature in the city is a few degrees hotter than out in the countryside. Cities are also known to be pollution hotspots. So in addition to flooding, temperature and pollution hotspots are also very common in cities. So this is a large team led by Professor Subimal who's here, and Akshaya was not here. And we have lots of people from climate studies and one from Mumbai University and also from mechanical engineering in IIT Bombay. It's an early warning, it's an integrated early warning and impact study. This has been funded. We're just about starting this work. It will involve it involves a lot of different moving pieces, but including temperature and pollution hotspots, for which we will do very high resolution simulations. I will just stop with this. There's one important difference between temperature and pollution. Temperature, well, okay, I'm happy to throw some physics. Please ask me temperature is a scalar. It's a passive. Well, it's a scalar that's affected with the flow. Pollution is not. Pollution has finite sized particles. They don't necessarily follow the flow. So that has consequences, and that's the kind of thing that we're going to explore with this. If that was not clear, please ask me. I will stop there and well, maybe I'll leave this on the screen if you want to ask me about this also, but I'm happy to take questions. Thanks, Tom. Finished.
So hyperlocal means what level of granularity?
Right now they're doing watt scale, but for this, for example, we want to do building scale. And of course, if it's indoor ventilation, it has to be building scale. So this, I didn't mention this. I wanted to stop within time, but we found that in the IIT Bombay classrooms, at the end of an hour and a half, class lasting an hour and a half, the carbon dioxide concentration. Anybody know what the carbon dioxide concentration is out in the real world? 400, right? So okay, now everybody knows. So 400 ppm is the in the classrooms. At the end of an hour and a half, it goes to 1600. 1600 is twice what is recommended by the Indian Society for ISHRAE. Somebody knows? Oh, it's ASHRAE. ASHRAE, not ISHRAE, but whatever. So the ventilation committee jokes that this is why our students look so drowsy. It's because of the carbon dioxide concentration. It's not because we are terrible lecturers. It's because of the carbon dioxide.
We see plants happy actually.
But we are trying to. The job of the ventilation committee at IIT Bombay is to design interventions that will make this better. Design AC and ventilation systems that will make this situation better. Because but yeah, so this is high resolution. This is CFD. This is CFD inside a room. This is also CFD, but it's at the building scale. We want to resolve individual buildings. I mean, you can't do that for the whole city, but you'll do it in a small block with input boundary conditions coming from large scale solutions. Okay, so it turns out we don't have the climate finance talk, but we do have our resident climate finance expert, not the one who's going to give the talk, but the other climate finance expert. So we will go to the panel discussion now, and I'll prod Trupti to talk a little longer than anybody else, so she can talk about climate service. Okay, so thanks everybody. So we'll the panel discussion.
Better you can try for indoor plants, you know?
Sorry? Yes. Yeah, we should get ready to model how much better the plants will grow.
It's interesting field, which is very good results. Even improve indoor environment.
Why did you said particulate matter doesn't just affect the flow?
Yes.
So that would depend on the size of the
It does.
Do we know actually what is the distribution for Mumbai? Pollution board should be able to tell us.
I doubt they do things at that level. I mean, it's not hard to model. But if you think of it as a spherical Chicken vacuum, that kind of thing, it's not very hard to model. So, I mean, these things follow Newton's laws. The Maxey-Riley equations are what particles follow. So you can expand the Maxey-Riley equation to first order, and you can see that if you have a curved streamline, particles get thrown away from the curved streamline. So if you have a, shall we do that? The coffee is here? Okay, how about that? Shall we take a 5-10 minute coffee break and come back? Yeah. By the time we'll set up the panel discussion. There's coffee outside. 6 panelists. we have Mr. Pranay Shah, who's with Tata AIG, who's an engineer. He introduced himself, so I will skip the people who already introduced themselves as I do an even shorter job. Dr. Laxmikant Naik is a co-opted member of the Dahanu Taluka Environmental Protection Agency. He was co-opted from TCS. Mr. Pranay Shah is, sorry, I mixed up your, Mr. Pranay Shah is with Tata AIG. Mr. Somnath Nandan is with Kalpataru projects. Before that he was with Tata projects. Pranay Shah is Tata AIG. Before that he was with Tata something.
Before that, like 23 years back, before the insurance industry, I was in Bharat.
Okay. The people whom you haven't heard from, Mr. Abdullah is from the Lodha Foundation. He is their executive vice president responsible for environmental sustainability goals. And Professor Mishra is faculty member in the Center for Climate Studies and head of the Desai's IIT School of Front you heard from Subimal already. So what I thought we would do is give each panelist a little bit of time to say something about how does climate change affect their area of expertise and vice versa, and after that we'll open the floor to questions from the panelists to each other and from the audience. So shall we start with Mr. Somnath?
Thanks. I will talk something which is not directly connected with the climate science, but which is impacting the climate. So I have been involved in the infrastructure industry quite a long. When you see infrastructure, I will classify the infrastructure into two sectors. One is that building, airport, this kind of assets which we are building. Also recently we have data centers. Then we have this kind of thing. It is like we talk about the building. So what we do in terms of reducing the energy, because of a direct design, then indirect design. So indirect design is like how we use more daylights, how we use the local materials, how we use the ventilation, natural ventilation. So this kind of thing we incorporate in the design. When you talk about the direct thing, it is the measuring the energy. So light emission bulbs, energy emissions, recycling of water, those kind of things. When you come out of the building, you see the landscape building. In the landscape, you have hardscape, you have softscape. The more you have the hardscape, that you are paving the things, you are generating more hits. You will take heat and it is reflective, it is not going up. Now all these things actually interacting with the climate, and we are seeing the impact on the results which you people who are the scientists, you are measuring it. So that's the one way of seeing it. Another part is infrastructure. When you talk about infrastructure, you can see that huge amount of roads, buildings, roads, flyovers, metro rail, bridges, these are coming across Mumbai. I am talking say the example of Mumbai. Whether it is solving a problem or not, that's the next question. But it is proven that the more you build roads, the more you are inviting the cars. The more you are inviting cars, more you are inviting the pollution, emissions, per se. So that means we need to go back to the town planning and the urban planning very seriously, which is not as of now well thought out in the industry or the government. So it is very imperative that institutions like IIT to find out something so that it should be driven in the policy level. So when people are designing something, they should think long term. I think there are some examples. I can directly from my work side, I have not done my groundwork on study. But if you see in US, there are at least 4 or 5 states where earlier between the communities they built huge roads. I think Texas or somewhere. 2-3 states are there. Now after 20 years they are thinking these are wrong. So they are demolishing these things. They are bringing back the rivers. They are binding the communities. A lot of things are happening. in many areas where earlier there were carts, now the carts have stopped. They are bringing up the pedestrians and using it. So I think that various ways, you know, I'm a civil engineer, okay. So as a civil engineer, we are interacting with the climate directly or indirectly. I think that's from my side. Yes.
Thank you. Dr. Laxmikant, very much all of you. Thank you very much for bringing this important topic for discussion. Basically, I am in the field of biodiversity last 35 years, and biodiversity is basically, I can define it as an important source for the industry, right? It comprising of different types of all biological, starting from the, just to explain you. So it consists the bacteria which converting milk into the earth to the largest animal on the earth, elephant, or the whale in the ocean. All these animals play a very important role in providing important services, particularly what we know Jivas, that they are linked to each other and providing energy, so energy flow, material cycling, then ecosystem stability, economic stability, because they are providing various ecosystem services which are very important to the industry. For example, the production, good production on which industries are depending on. For example, forestry, fishery, maybe fiber, timber, leather, mining, petroleum. So all these industries, they require very important biodiversity for biodiversity resource, which is very important. And as per the World Economic Forum, latest 2025, they say they're not addressing biodiversity is found to be very important risk for the industry, because they have surveyed S2HG report. They have surveyed many industries, and they come across to find out that 33% is biodiversity risk because they are not properly addressing. How this industry affecting biodiversity, you know very well, that because of industrial pollution, urbanization, then climate change, then hunting, killing, poaching, right? So these are the various ways. So there are various laws which are also protection of the biodiversity. You must be knowing the Vicky Brinjal case, right? So how that plasma of the local Brinjal species was transferred by Mohiko to foreign collaborator, and that was without the intimation to the National Biodiversity Board, and that has come to the arrest of these benefits. Second, you must be knowing that how Salman Khan was arrested because of Wildlife Protection Act. So it is personal as well as is the risk also. So and then recently, I think Sabarimala. So court has recently given a decision that people, they used to dump their waste into the Periyar reservoir and they used to burn it. And so under Wildlife Protection, because it is tiger reserve, so it has been stopped. So in this nowadays, the biodiversity become very important, and it's becoming important. We can say the bone of the economy, because we are agriculture-based industry, agriculture-based economy we have. So biodiversity plays very important role, and it provides various economical services which are very useful for industry to mitigate their regulatory risk also. And nowadays, the government is also very strict on how they should do the biodiversity disclosure on biodiversity. Now, particularly SEBI has asked for all industries, corporate and industries, to produce BRSR report or ESG report, must be CDP report. So all these reports, TNFD reports, so they are concentrating on how the industry impacting the biodiversity and what biodiversity can be restored by the industry. So we come to the next part, how industry can helpful. So industries, they are having big resources, and even they can help for the conservation of biodiversity. Particularly, they are having big land holdings, right? So that land holdings can be properly done, so as to they should know what sort of biodiversity they have and how the biodiversity they are impacting biodiversity. They should have a biodiversity impact register, how activities can be minimized. And in this way, there are quite awareness among industries too. They are coming up with these reports and lot of still, but there is lot of impact on the biodiversity by industries. And I feel that the basic concept is that, which you know, Vedic principle of sustainability. Sarve Pishubhina Santu, Sarve Santu Niramaya, Sarve Bhadrana Pashyantu, Ma Pashyat Dukkham Atmavit. That whatever industry within which I am operating, that industry should take care of small organisms which are helping them to bring the stability to the ecosystem. So in this way, what I feel, all of us should be very careful about how we are impacting the nature, forget about industry, but even we are also impacting the nature. How we can help for conservation of biodiversity practice, that is what I feel the important message I would like to give, that the industries definitely they should take more and more efforts to help for the conservation of the biodiversity, and thereby they can get rid of from regulatory so many risks which are posed by the different issues related to biodiversity. Biodiversity cannot be a risk to an industry, but not properly addressing the biodiversity will be a risk to the industry and industry. So this is what I feel. It's just short, maybe I exceed 5 minutes. Sorry for that.
I have questions that come back to you.
Right.
Thank you, gentlemen. So, very interesting sessions that we had prior to this, and thank you for the invite. So I represent the insurance industry here, and therefore it is important to start with some disclaimers to say that today whenever we face the consequences of climate change, which is largely for us it is largely floods, storms, cyclones, earthquakes, right? So these are the big ones which are relevant to insurance, and these losses for insurance industry, they account for only 10 to 15% of the overall economic loss, right? So as an industry, as a country, we have a large amount of under-penetration of insurance, and therefore the insurable is much higher, but what is actually insured is just 10 to 15% of the overall economic losses. So that is the first part. Second part, like I said, what is amongst all the consequences, which is again a very wide range, but what is more important is storms, cyclones. In fact, this year we also had a hailstorm in Morbi, right? So hailstorms are getting to be more important, and there is floods and earthquakes, right? So these are the and within floods also now we see increasing tendencies of cloudbursts happening, right? So we had never seen those instances earlier. We see increasing instances of unseasonal rainfalls, right? So areas like in Rajasthan, areas in Gujarat which are perennially dry areas, they have seen rainfalls now. So those are causing economic impact. So those are leading to insurable losses, and that is how the industry is being impacted. Personally, I take care of MSME within Tata IIT, and before I get on to MSME, I want to also share that these climate change causes a significant impact on crop insurance as well. So we do have significant losses in crop segment as well. Within MSMEs again, the impact, so there is property and there is health, right? So the impact on health insurance is relatively long term. So things like pollution, etc., they cause a long term impact, but not very directly correlated to the consequences, and therefore not very measurable right now, right? So if we only talk of, let's say, property and for MSMEs, then the industry must be paying claims more than, on an average, of more than 1,000 crores every year. Okay, so that is the impact that we are talking about, and that is the relevance, right? So and this would mean anywhere from 5 to 15% of the overall claims that we pay as an industry, right? So in the property line of business. So this is where the significance of climate change comes in. Okay, so for us, we have seen that the frequency of natural catastrophes are increasing every year. So on an average, we have seen last 5 to 10 years, every year at least we have 2 cyclones and 1.5 to 2 floods, right, which have a significant economic impact in terms of insured losses, right? So these instances are established, and all of us are aware on what is on the fact that there is an increasing trend in natural catastrophes. But where we need some research, where we need some predictability is in terms of what is that rate of increase, how predictable is it, where are we leading to. In terms of what is available right now, there are long-term projections. 50 years down the line, this is where we are going to be. But for the insurance industry, again, what is relevant is, where are we going to be 3 years, 5 years down the line, and how will that change the kind of product, the pricing that we as an industry offer, right? So that is where it tends to get more relevant, right? So in terms of what we as an industry would how we deal with it right now is simply that we have collaboration with modeling agencies, right? So there are established modeling agencies who work on hazard and vulnerability, and they provide scores. So we have information from them that we use today for risk selection, whether or not to insure it, and also for the purpose of pricing, right? So this is how we use it today. But there are limitations to the models that are available. In fact, there is information available that requires manual intervention to assess the risk right now. So in Tata AG, we currently issue more than 5.5 lakh property, more than 5 lakh property policies, right? And it may not be feasible for an underwriter or to have a manual intervention to assess each and every risk. Okay, what is therefore more required is information that is available in a synthesized format to understand what is the hazard and vulnerability, and information that is available at a more granular level, because when we issue a policy, it is at a particular address and not at a particular ward or a pin code or a district, right? So which is where most of the work is currently happening. So how do we reach to that level is the challenge that we have, right? So the other part is also in terms of whatever inputs we have from the models being incorporated in the pricing, but the unseasonal rainfall that I talked about. So if we have, in fact we were having that discussion earlier as well, today the unseasonal rainfalls are happening, and they are happening, we have some predictability, 2 days in advance we know what is the rainfall going to be, right? But for the insurance industry, it does not help to know 2 days in advance, right? For the insurance industry, if one wants to know that for that particular location, what is the frequency of unseasonal rainfall going to be for the next few years, right? That is the scale at which we want to understand it. And I think as a phenomenon, we have had limited study in that area, and that's where I think we can collaborate effectively with the academic community as well. So that's all I wanted.
Thank you.
Hi. So Lodha Foundation is the philanthropic arm of the Lodha family. The goal is to impact the GDP per capita increase of India in the journey of the country from being a 3,000 GDP per capita to 3,000 GDP per capita economy. So we have taken up 4 areas. One is gifted education, second is innovation, third is sustainable urbanization, and fourth is Indian culture. The reason why we have taken sustainable urbanization is that it has never been seen that an economy has grown without urbanization happening in that economy. All global developed economies have urbanization close to 80%. We are at early 30s, and even China, such a big huge country, also has. So India is going to move into a very high urbanization in the next few decades. Certain estimates that we follow suggest that close to 100 million households will become homeownership. That means 500 million people will move from towns and villages to cities. Now that is equal to housing the complete US or complete Europe all over again in the next 10-15 years. It is unprecedented as never happened. Now this urbanization is expected to feed growth and be fed from it. But the picture is not as rosy as this. So So urbanization and high density brings a lot of problems also. So while on one hand we can say that urbanization is a growth engine, on the other hand it can actually become a drag on the economy. And when we are solving with density, so there are multiple problems that we face independent of climate change. First is that how do you urbanize? A city is normally we call that as a labor market. It's nothing else. And people are coming in to do something, and those labor markets will happen around economic activity. So there will have to be an economic nucleus around which all of this will happen. So naturally, the bigger cities will keep becoming bigger and a lot denser. And this density is expected to solve the problem, but the problems that it brings is that, both in terms of emissions and both in terms of the material use, energy use, and if the urban planning is not done well, having these floods and urban heat and all of that. On one side, we, in the era of not considering climate change, we could do these by simply taking into account some factors and prescriptions which were very static. You take historic data, you use that to do the planning, you orient the development in a manner that is aligned with the prevailing winds and make the master plan breezy. Now, and you do not expect that there will be poor air quality. Now, so what has happened is that things have started to change. Now, everything is, if you go to the floods, for example, if you look at precipitation, it's a climate change aggravated problem. If you look at heat risk, so the urban heat island or the absorption of heat and being radiated is one, but then the heating up of the ecosystem is the other. If you look at the air quality, and you look at the air quality in Mumbai, which we are thinking has nothing to do with it, everyone is now saying that it is a local meteorological issue which is causing this inversion and not enough of wind so that everything is getting stuck in this shorter height. So the problems are becoming much more aggravated by climate change. And there is no single answer how to solve them, because the climate change issue itself is so dynamic that if you take a slice and you solve for it, in no time that assumption will go bad. So what we are trying to do at our certain of our developments, especially Palava, which is the city development which we thought can be a model for sustainable urbanization in the country, and some other developments also which are big enough. We are trying to solve for these problems. And when we are trying to solve for these problems, we are actually getting stuck in terms of how to estimate for climate change and then how to incorporate aspects which make the development more resilient. So while mitigation is one thing, now adaptation is becoming much bigger. So simply an energy transition thing is not what is going to solve it. We need to be really be able to adapt. And in fact, if you look at the national scale and global scale, now there are talks which are saying that you mitigate, if you can't mitigate now, you adapt, and if you can't adapt now, you migrate, and if you can't migrate, you. So it's a no end to this problem. So that's why we are here to learn from people who know more than us. We will be happy.
Thank you.
Thank you, Ravi. My thought is possibly connecting what once possibly left there. I do not see climate solution for industry as a standalone problem, because this solution is the economic wide. And if I give a background, we are talking about climate solution for a country, where in one way we have the developmental challenge, we talk about equity, we talk about zero poverty, we also want to be net zero. Then we have MSME sector which is lagging behind and we need to support to further growth. Also we have, possibly we are thinking of energy access, because we know that at some point of time we are kind of reaching to the dead end of the oil resource, and also we have to create jobs. So this is what the background of the country, and where we need to think looking for the climate solution, possibly for the industry who is responsible to feed the people and also responsible for the consumption of the people. So the thought over here is that there is no doubt that climate impact is not there. Climate impact is there. We have enough of evidence, but the challenge is that climate impact is not generic. That is what possibly everyone views that climate impact is not generic. It changes at local level, it changes at the regional level. So we know there are solutions, but we don't know that there would be also solutions that needed for the local level. What we need possibly for the first hand is that we need local level science, local level policy. There is some progress for the local level science. We get into the grid level. Possibly Ravi was talking about that we want to get into at the also building level. So we are getting into this, but still there is a long way to go when we talk about local level science and possibly targeted policy intervention for the local level science or the impact. So how I see is that this entire solution is into the four parts. One, there are enough of evidences we know and we need to address it. Second, the economic system has changed. It is going to change more, and accordingly also our production consumption pattern is going to change, which will have to create more burden on the industry. Third, possibly the biggest role is that there is a changing role of the stakeholders. Like investor, they want to see the ESG score before investing in the industry, and also the age of social media. If your production, if your level 3 is very high, if you are not green, consumer is going to reject it, right? If you are just failing one emission test, your product is out of this market. And the last one is that if you look at the technology and innovation, we have enough of now heat resistant technology, we have enough of cool resistant technology. But the question over here is that, are they scalable? Are they affordable? And also, are we in India, we are equipped enough to develop the technology on our own and also make it scalable? So there are few pointers possibly what we need. Some of them are enablers and some of them are barriers. So as I said, local level science, local level policy, the growth has to be really fast to plan the policy. When it comes to data, we do not have enough public digital infrastructure. So suppose if you want to do monitoring, if you want to do forecasting, you have to depend on an agency, you have to depend on an institution which will create the forecasting model. So there is no public digital infrastructure. We have a long way to get into where we get all our data in one and we use this to model the forecasting. Most crucial, we have regulation. Mr. Naik was talking about DRSR. So at least there is some pressure is that you need to publish what you are doing. And that typically works as an enabler for the industry that you need to do something because you need to publish. And then it comes to regulation, we have enough, we have PAT, we have carbon market, we have REC, we have RTO, we have lot of carbon investment that we are getting in the form of the climate. But still everywhere what are the challenges is that there is a long way we need to go till the time we reach to the climate solution. And last point is that, are we involving everyone who are responsible to give the climate solution? I'll just give a typical example. The plant, the TVS plant in Chennai, the impact over there is very different from the plant in the other place of the India, right? But here, what we need is that we need the ground level intervention, we need the local level planning, and possibly there we are not involving all the stakeholder. So one is key decision while making the local responsible and also making the ground level implementation, whether it's about a industrial cluster, whether it's about a climate smart agriculture, whether it's just about a emission testing, everywhere we need the stakeholder intervention.
Thanks. The last word to Subimal before we open to questions from me and then.
Thanks, Ravi. I'll keep it a bit brief because I have already introduced climate studies. So one of the things I'd like to mention is, I was talking that climate studies, the journey started in 2012, our center's journey, and now we are in 2025. So initially, when we started our journey, we are more interested in writing papers. Of course, we are now also we are very much interested in writing papers, but we are more interested in writing papers, doing our research, looking at very nice plots which explains many of the monsoon processes, many of the heat wave processes, and so on and so forth. And yeah, that was our satisfaction. But starting 2020, maybe during COVID and post-COVID time, we realized that we have to move forward and we have to contribute more to the innovation ecosystem, because IIT Bombay was also upgrading, thinking of upgrading itself from a initially it was undergraduate teaching center, then it became postgraduate research organization. Now it's more like innovation ecosystem IIT Bombay is promoting. And being a part of IIT Bombay, we also need to focus more on innovation, invention, and so on. And then when you're thinking of that, of course, we know that necessity is the mother of invention or innovation. So if we have to really understand where to innovate to make it really successful, we need to understand what exactly is happening outside. It's very difficult for us who are sitting inside IIT Bombay, who has less connection with the outer world, because we have everything inside the campus. We have shops, we have playgrounds, we have classes, we have residence, we have everything. So it's very difficult for us to really understand what exactly is happening. And more importantly, we need to work with the practitioners. And what we have realized from climate studies is that we are unable to understand the need of outer world, need of people. And if we have to really understand the need of people, we have to work with the industry and learn from the industry what exactly are the needs, what are the problems. And then we'll see that in what way our knowledge or the knowledge which is getting derived by the students can they be used to really improve the tools to make people's life better and to address the necessities which are arising now because of climate change. This is what is very important. And this kind of changes we are seeing. I mean, 20 years back we were never worried about climate change. But now we are seeing increased number of extremes. When I was in Standard 5, I cannot remember that I studied anything related to climate change. Now when I am looking at my daughter's social studies book, there is a specific chapter on global warming and climate change. And that shows, there is a need, and we have to understand that the kids also have to be, climate literate. That is what is very important. And so that is what we have to understand. We have to understand what exactly people really want, and so that we can develop the correct tool to develop our innovation ecosystem. The second thing what also I feel is, one of the things which we are now seeing that there is a revolution that is taking place in data science. And we are also thinking in what way we can really use the data science to upscale. Upscale is something which is very important. We are developing for a small region, a small thing, but how to really upscale, and we are using data science. Of course, in Western countries it was very successful. I mean, people are successful in upscaling because there is a pattern. There are a lot of people can afford, so they follow a specific pattern and so on. But in our country there is a huge diversity, which is of course one of our strengths. But at the same time, if we do not have diverse data set, that becomes a weakness for many of the upscale models. Because we develop for one region, one group of people that may not affect and that may not be useful for others. And there we are fairly badly. So the challenge here is that now the idea here is that you have to collect, monitor a lot of information, being in climate, being in societal, anything. You have to collect a lot of information from diverse background, from diverse sources. And then it will come in a diverse way. So the information will come in a diverse way. How to really process it so that the core scientific model can understand it and process it. And then when we disseminate, then again we have to work with the stakeholders and make the tools really climate smart. So these are really the major challenge what I have felt over the last few years. And we have to learn more about this, how to really make this entire innovation ecosystem or climate entrepreneurship ecosystem really successful when we will work with the industry. And that's one of the major purpose for this event.
Thanks, Shiva. So I will open the floor to questions from the audience.
Hi, my name is Mansi. My question is to Mr. Pranay. So you were talking about insurance and MSMEs. So right now, according to SBI, the insurance penetration in MSMEs is only 5%. And as far as I know, because I also work on MSMEs, the insurance is majorly for like industrial accidents and so on and so forth, with varying degrees of what is covered in that. So as somebody who's in that field, how do you think of scaling up, because MSMEs are difficult sectors, there's so much informality and so much unorganized. How do you think that will scale up, and how do you think insurance products related to climate change can be introduced there?
Sure. So when we talk about penetration of MSMEs, largely today the number of MSMEs which are registered, both formal and informal, on the Udyam portal would be around upwards of 7 crores. Okay, and out of that, around more than 3 crores would be formal registered, so organized MSMEs. And if we look at the number of loanees, okay, that has already exceeded about 1.5 crores, right? But if you look at the insured MSMEs, that should be in the range of 80 to 90 lakhs, right? So that is where we are, in terms of, and again, the reality is that most of those 80 lakh MSMEs have taken insurance because the bank insisted upon it. Okay, so that is where we are. So right now, in terms of increasing the penetration, it is more about reaching out to those MSMEs. Thankfully, the social media, etc., is helping the awareness, and now we see that the affordability issue is also relatively a lesser issue than it was earlier. What is most important for the insurance companies is to provide access and to give value, right? So value both in terms of establishing trust in the industry, because that has also been traditionally an issue. So in Tata AG, for example, we as a principle, we design products in a as comprehensive a way as possible, so that we are fair and transparent and objective on what is covered and what is not, right? And also in our claims processes, similarly, unless there is an explicit reason, we don't decline, right? So it's not the other way around. We don't find a way to decline, we find a way to pay, right? So those approaches, they help to build trust in the industry, right? So all of these things, providing right access. So now we have, like, even in Tata for MSMEs, we have a lot of products available on our website. We deal with all the channels, including bank assurance, agency, broking, etc. Right? There are other affinity channels as well. So one is distribution, and a lot of work needs to be done there. Okay, distribution is the biggest piece there. But apart from that, the product design, the claims processes, right, and the trust factor, right. So these are the elements that as an industry we need to work on to have more penetration. Thank you.
Can I ask a related question?
Sure.
You said the number of people who could be insured but are actually insured is about 5-10%. Was that all people, specifically MSMEs that you were saying?
So I was talking about MSMEs, and the penetration right now, if you look at the 7 crore number and 80 lakhs, then it is close to a 10%.
Sure.
But again, what people who are in informal sector, they are not insurable in any case.
Yes.
So in the formal sector, MSMEs are insurable. There the penetration.
Okay. So here's my question.
30-40.
So in making industry resilient to losses from climate change, if you made the number 90% instead of 10%, magically, they have magic ones, would that solve the problem? Because if there is an extreme, it's going to impact one region, not every region uniformly. So if you increase coverage enough that you have a geographically diverse sampling of developing insurance, would that already solve the problem, or is is it even not solved with that?
Also, no, so the problem, okay, when we talk about the problem, what is the problem that we are talking about? Is the problem the value for money that the MSME wants? If that is the problem we are solving, then this will not solve the problem, right? So we have to first provide that value and trust, right? So establish the trust, provide the value. If we are solving that problem, then the other problem that you talked about solves the problem of volatility, right? So if we have a large population being covered and it's only a pocket being impacted at any point of time, so volatility is lesser. But today, we have the reinsurance community who solves the volatility problem in any case, right? So that is available even today for the insurer.
Thanks. Aniket, I saw first, then Vishal, then.
So one question that I have is that, in fact, two questions, so I'll just shoot them one after the other. One is that, in your risk model, the models that you are already using, how well are they able to actually, estimate risk against the actual loss and damage? So has that been corroborated? That's one. Because that would matter in terms of insurance, either parametric or non-parametric. So that's one question. And the question for answer is that, when it comes to urbanization, how do you actually estimate how much urbanization is going to take place in any agglomeration? Because, in terms of economic activity, as you rightly said, and the labor markets, economic activity is undeterministic, pretty much, in the sense, especially when it comes to manufacturing. Manufacturing is now no longer the mainstay of our economic thrust after post the 1991 reforms. So now, how do we look at this? How do we look at investment? How do we look at the migration of labor? How do we see these agglomerations developing in terms of, how do you do that?
Okay, so on urbanization, I mentioned that it's basically a matter of economy, and some economic nucleus is needed. So if you look at the big developers in the country, in last 2-3 years, you will see that. So if you go back 5 years, you will see that all big developers were very, they had concentration risk. They were working in one market and they were major in that market. So you would see that they have identified the key cities in India which are already economic hubs, and everybody has started to move into newer cities in that small group. So if you look at us, if you look at Godrej, DS, all of these, so there are very few cities where everyone is now going in, because there are existing economic activities going in there, and the expectation is that where it is already at a maximum, there it will grow. So while there are no models per se, the understanding is that that economic nuclei will actually become the right.
And so, your question.
Just before I move on to the first question, just continuing the urbanization discussion. Even today, if you look at our own data, 60% of the claims that come for MSMEs come in urban areas, okay, tier 1 and tier 2 cities. Okay, so while we are talking about increasing urbanization and that is the way forward, even today, most of the economic activity of MSMEs is centered around the tier 1 and tier 2 cities, right? And for the models that we use right now, we don't have like a third-party source of information on what is the quality of construction, what is the adherence to local municipal regulations, right? So those are elements that we would love to have in our model, which tells us the more accurate output on these things, right? So and on your first question, there is no published data about correlation. Okay, so where of course within our own data we see positive corroboration of the models, which means that wherever we have taken the risk as low risk, then it is relatively a low risk. Doesn't mean that we don't get claims there. We do get claims there, but relatively it is lesser. Okay, and the second corroboration comes from the reinsurers to say that within Tata AG, because not everyone has implemented the model, right? So within Tata AIG, in any single event, the number of claims that we get are lesser than, or relatively lesser than the market share of Tata AIG in that market, right? So those kind of independent collaborations we do have, but not a strong correlation. And if you ask me scope for improvement, there is a lot.
Vishal.
Yeah, my kind of question is speaking on the thought that Trupti and Subimal both mentioned in different ways. Trupti said digital platform, lack of digital platform is one bottleneck, and Subimal said diversity in inputs required for training models and the diversity of outputs that is required to actually implement things on ground. So my question to all the four guests actually is about, are your organizations thinking about common digital platforms, common data kind of data formats, anonymity of that data, what variables matter? This is a bit also about what you just said, that you would actually benefit from supplementary data, which is right now not with you, but it could be with some other people who, if they are willing to make it anonymous and give it to you, you might be benefited. So in that kind of direction, what sort of efforts are done, and how do industries see this, an availability of a common data format, data platform? And this question is to all four guests. And if you want to reflect on that.
We welcome a common data platform. In fact, at Lodha Foundation, we have been releasing a lot of Lodha project data on our website. Also in our urban heat studies, in terms of our flood risk studies, in terms of embodied carbon data, energy data, Urja, all of those programs we are actually putting out there. And we are also engaging with the DISCOMs to allow us access anonymous data at the building scale so that certain decisions can be taken. There is one more very interesting thing is that it is not only, so this diversity of data is a very interesting point. I do not have all the data. So even if I bring all my data, we may not be able to do the analysis. Similarly, the DISCOM doesn't have all the data. So we were having a discussion with Tata Power, and they have these smart meters, and we are trying to check the signatures of the equipment usage. But they were not getting very accurate outcomes from that exercise. Now the point is that they do not know the direction of the building, they do not know the material of the building, and they do not know the occupancy. Now the occupancy data is available in the access control systems that are there on the project, and the direction and materials are available with us. So basically these two agencies have to come together and bring this diverse data so that a meaningful outcome can be achieved. So this is a very, it's exactly to the point. We cannot do anything with our own data. Maybe a lot of other diverse data has to come in and be taken into one pool for that, and then for the necessary.
I just want to add something. I think one of the slides that were mentioned about the digital twin. So I think it's very important to have every city or the habitat to have a digital twin. So currently, you see, some countries they are doing their own city digital twin. Primarily, they are focusing on gas pipelines, services, utilities, those kind of things. It is important to bring up the data learning after the timeline. Those kinds of data has to be going inside that, so that whenever someone is doing something, whether it is a developer or infrastructure builder or the local municipalities, they should be able to utilize the data. It is important to have that kind of data.
From an insurance industry perspective, we have a body called Insurance Information Bureau, and that body is authorized to collect information with a regulatory mandate from the insurers. Okay. So far, they have done a good job on motor insurance, for example, and they are getting into other lines of business. Property insurance, they are also publishing. Other lines of business, they are yet to, but the progress I would hope should be much more. And so in fact, in earlier times, so during the insurance industry was in a tariff regime before, so it liberalized only in 2001. Relatively a fledgling industry for the private insurers. But before the liberalization happened, there used to be an organization called Loss Prevention Association of India, and that organization was responsible for collecting all the risk information, new emerging trends in risks, etc. That activity right now somewhere is lost. I mean, it's and responsibility, collective responsibility of the industry that we need to take up as an industry, especially pertaining to the risk parameters, because the policy and claims related information is being collated by IIT in some form, but the risk related information currently as an industry is not, and that's definitely an area of work.
What you are saying that quite it is available on the data, because whenever I need to know, suppose I want to know the impact of the power industry. The power industry CDP report is available, then sales report available, then a lot of information is available. So that is not the issue. So whenever just I was working for impact of the solar panels on the birds and bats. So like that, so it was quite available. So what I mean to say, data that in this sector particularly, that data availability is fantastic. I mean, we can work out that suppose I have to work on Himalaya, then what sort of data I need. If I have to work on Kerala, then what data I need. So that sort of quite good amount of data is available on public level. So that is not the issue. Besides these different reports from the biodiversity, particularly National Biodiversity Board, State Biodiversity Board, then Pollution Control Board, and they are quite available data is fantastically available online, so there is no issue. So that's why whenever I had to work on some particular industry, before that I should know that what are the industrial impact, and industrial impact may be not same. Gujarat, impact on the Gujarat is different, impact on the Kerala is different. Because environmental conditions are totally different. There is species specific also. What species specific I am talking about, what habitat I am talking about, what ecosystem I am talking about. So the biodiversity, when we talk about the most important part is whether ecosystem diversity, species diversity and genetic diversity. So these three are important points, and that data has been quite good amount it is available. Standard literature is also available. So nothing issue on that, only we have to channelize that what may be the likely impact and what sort of further management plan can be suggested for conservation, maybe species, maybe habitat, maybe issues.
Sure, I think are the variables already identified not only for biodiversity field but also because if the variables are tagged, then maybe the question, I mean the real example you were giving, right, Mr. Shah, that the data that is required for I mean that you would be benefited. Somebody else, if they would have tagged this data, you would have been benefited. So I just wanted to know, are the variables, number of variables known, are these tagged, or is such an effort being made actively in the industry right now, or there is a need of, because I also see some industry might actually, I mean, we don't want to step on their profit making thing, right, by just giving away data, and they would not want to do that. But if some data can be anonymized and put in open, they could also be benefited by their own, by somebody else putting in such data, as well as like On said, if some foundations have put in some data, that could be supplemented. I mean, there's some scope for that to happen if some common, I don't want to call it data dumping ground, but you get what I mean, an archival of data will happen.
There is some effort going on, obviously. People are trying to create these frameworks within which the data can be generated. But obviously there is nothing formally out there, but there is quite a bit of effort going on. RMI is working on the residential energy data. There is a platform called Define, which is working on the emissions data coming out of industries. And there are still lots of consultations are happening, alignments are happening. This is just a very, I mean, this has all started happening in the last 2-3 years. Post-COVID, I have seen more action here. So I think it will take some time, but some sort of an alignment. Embodied carbon there are agencies like, IIT is also.
Before I let Devjyoti ask a question, I have a related question about, Kruti was saying it's the age of social media, so if people know who is polluting how much, they'll be able to choose vote with their money. What government, what regulatory work is required to ensure that people actually report how much they're polluting properly? Is that known thing? Is it already there? Is it?
That's what is PRS, right? Business and responsibility. So top 1,000 listed companies they need to publish every year, and all the parameters that have been identified. So just quickly going back to official questions and also what panelists they were saying about what is available. So if you look at, we have from the industrial data what we get is the Center for Monitoring Indian Economy, popularly known as CMI. And till now the format is that we get the energy consumption data. Nobody gives what is the emission data or what is the carbon data. So till now they publish, like you can get it at the plant level also, what is the energy consumption data. And being a researcher or any other person who uses that, they try to use the IPCC method to convert the energy consumption into the emission. So I think what is required now at the broad level, what need to disclose and which format, that is the kind of a common platform that should come rather than industry specific. This should have to have a broad comprehensive framework where each industry they will report what is relevant to them. Because industry specific again the uniformity issue will come. Right? What is possibly if it is from a steel, what is coming from one industry, coming from the other industry, there may be uniformity issues.
No, you are talking about external reporting, right? So they have specific standards. KNFT, they are having their own standards. CSR report, they are having own standards. Then we are talking the ESG report, they are having own standards. Every company has to report based on their common questions, right? So that common question, perhaps my answer will be written as industry specific. So power plant will give industry specific information. Steel plant will give their. So in this way, that we are talking about carbon emission. That data is best available with the CSR reports and with ESG report, BRSR report, which are readily available on the
market. See, it's again we need to get back to the understanding that BRSR is self-reporting. So somewhere if you look at this entire
BRSR is by SB saving, it is compulsory reporting. ESG is a voluntary. If you want, you can report. If you don't want, you can.
BRSR is also mandatory for the top 1,000 and again it is voluntary. BRSR, when there is self-reporting, we have a lot of flexibility on reporting, at least on the leadership indicator that how do we like to report. So there may be some ambiguity when it comes that it is end of the day it is self-reporting and I will always try to show what is being done well rather than what is being not done well. So
I think that these reports are also tested by the third audit. Third-party audit is done and then only these reports are released. So what I feel that quite reliable reports. I mean, you cannot say that whatever I want, good things I will
no, but it is reliable and we do use it in our research also. But what we are possibly discussing here is that what may be more robust way to get the data in one place on a common parameter. So when we talk about modeling, when we talk about the impact assessment, that we can get to it.
And also the quality.
Also the quality.
So, well, I'm at a very nascent stage of this research on climate risk insurance. So I have a question, rather 3 questions to you, Mr. Shah. So one is, I'm quite curious to know what are the perils which are covered by the Tata AIG disaster insurance, number 1. Number 2 is that mostly, highly likely it's an indemnity insurance. So how does Tata AIG tackle how does the insurance cover tackle the basis risk? Because it's a climate risk, And third is that I have a question like, since the disasters are increasing, with the frequency is increasing, the intensity is increasing, it's projected to increase also. So there will be increasing risk premiums as well. So how do you feel that there is a change in the adaptability behavior of the MSMEs towards this increasing risk premiums, what is the challenges faced by the say particularly Tata IIT, or what challenges do you see that is going to come, and what are the probable solutions to the industry?
So I didn't get your second question completely. I'll just answer the first and the third one, and then you can repeat the second one. So in terms of the first question, the perils that are covered, we cover all the natural catastrophes. There was a standard cover prevalent in the tariff regime, and the covers that we are now providing is includes things like hailstorm, volcano as well. So all natural catastrophes by default covered. For MSMEs, we kind of put an additional control to say that if you don't want, please do it in writing. Okay, so we make sure that people are aware about what cover they are seeking if they are seeking a reduced cover. So it's a pretty wide range of perils cover apart from natural catastrophes, and it's a pretty standard one for you. So that was the first one. The third question, increasing trend in natural catastrophes leading to increased pricing. Yes, it is happening, and the uptake of MSMEs based on that, there is resistance, but I won't say that there is drop in uptake. So they understand the value, and whoever understands the value, they will go for insurance. So the drop in uptake. See, the good part in asset insurance is also that the sum insured is in the insured's control, okay? And how much you want to self-insure is in your control. So if the price increases by 10%, I can choose that I will retain 10% risk on my own and insure only 90%. So how much premium to pay, therefore to that extent is in your. So a lot of people choose to underinsure consciously. A lot of people, majority of MSMEs choose to underinsure unconsciously. Okay, because it comes to the bank, right?
Okay, so basically the second question was about usually there is always a mismatch between how much the damage actually causes and actually it is the sum that is being insured. So that mismatch happens only because of that's the general problem of the indemnity insurance. So how does the insurance company how does it take care of the localized problems of this faced due to the natural disasters or the mismatch? Yeah.
So it is more of an awareness issue because from an insurance product design point of view, there is nothing much to worry about because if we are getting reduced premium and reduced exposure, we are paying reduced claims. Okay, so it balances out. What is more important is that the MSME needs to be aware of what is the value of insurance that one should take, and that the value should be commensurate with the total exposure that one is having at a particular location. So that awareness, because most of the times what happens is the bank approaches the insurer on behalf of the MSME, and the bank is interested in the loan amount. Not every time will the bank be aware of what is the actual exposure. That is why the underinsurance happens. So that responsibility of taking the policy once that is shared by the bank or by the insurer should be there with the MSME to understand whether there is adequacy of insurance. And we do everything to spread awareness. We do everything to inform them. So there is a customer information sheet that goes with every policy. It's a regulation now. Okay, so regulator is also doing a lot to make sure that the customers are aware. But still, not everyone goes to the policy. That's a challenge that we have as an industry.
So I think we have time for one last question.
I just, on behalf of the students are thinking about this question, but they are not asking. There are three parts of this question. The first question is, what are the possible job opportunities for the students who are doing masters and PhD in climate and sustainability? This is very important question because 20 years back already the students were interested in climate or some. Let's say some of the students, they are not joining job, but they are young entrepreneur. They are trying to contribute to the innovation ecosystem. They are coming up with startups. In what way they can get help from the bigger industry? And the follow-on question is that, let's say some of the students are developing a patent, patenting something. In what way they can communicate with the industry so that for a possible licensing? So these are essentially 3 questions for all of them.
As far as ecology and all these things are concerned, what I feel that besides whatever we are doing ourselves, we should have the ISO 20001 course, right? Ocean Rating 1001, energy management system. So these are the new requirements of the industry. Unless and until, even though you are expert, you know your knowledge is there, but unless and until you have ISO 20001 certification or internal auditor or external auditor, so that's what courses are there. So I think along with this, if you do, then definitely that will give a more weightage to your CV and more opportunities for industry to do, right? So what I feel that there are so many sustainability courses also online or regular courses. Besides that, unless until you have some job-oriented courses, because these are particular requirements for the audit, environmental audit, or occupational health and safety audit, or energy audit. So like this, so there are a lot of demand for this. And I think that along with this, these are some of the important courses which will be very useful for students to take more and more actually. As an auditor, environmental auditor, or as an energy auditor, or as an occupational health and safety auditor. So in this way, that will be very useful to you.
See, one to mention about the structure. So I am structural engineer. So, but you see the shift which is happening. So you see the traditional engineering companies. You take the names. I can take the names also. Like say WSP, AECOM, Atkins, really, these companies. Earlier they were traditionally detailed design companies. They are doing the civil engineering problems. But if you see gradually they are shifting towards two areas. One is digitalization, that is creating some models or AI or ML or that kind of utilization of data and giving particular solution to a bigger client, say railways, say airlines, those kinds of things. Second level, they are doing the climate modeling. We are doing at the research stage. We are doing at the commercial level. So suppose some local municipalities or they come to a particular company, they give me the solution. So they do climate modeling. But that is happening very fast in other countries. If you see one of these companies, they have 400 engineers in the environment and water department. They are sitting in India, but they are working for other countries. And they are doing this kind of research and climate modeling for various clients across the world. So I think opportunities are there, but you need to tap and find out how you getting the way out to that kind of level, what they are looking for.
In the insurance industry, in fact, building and defining the catastrophe risk models is where the opportunity is, and I think there is quite some work being done there as well. Students who have done a bit more research there definitely get.
Yeah, so Vishal manages our climate risk. So there are specific jobs on that. Now see what started mainly as acknowledgement and compliance has now very well been understood as business value. So all companies would want to analyze the climate risk that they are confronting, and I believe that within a very short period of time, the companies would themselves go deeper into their value chain and start analyzing what sort of climate risk exists there. Now these climate risks can be evaluated for taking decisions on how the business is oriented and at the same time designing solutions to overcome these challenges. So there can be a business angle to the climate risk, and there can also be the science and engineering angle to the climate risk, and both these avenues have opened up. there is no way that this opportunity is going to come down in any manner. This will only increase. In fact, I feel that the talent in the country in terms of the climate risks, in terms of various environmental solutions is very less. And currently experienced and differently experienced people are trying to use their limited capacity to try to solve those problems, which is not solving them. We will need resources, the industry and the economy and country. I mean, we are at a stage where we are at the most vulnerable and the most hopeful at the same time. So I think we need resources like whoever you
No, what is important for all industry, climate change is a very important aspect. So many people used to ask me, Doctor, what you are doing in IT industry? I was anticipating, what you are doing in IT industry? So when I was road project, they said, what you are doing in the road project? So many avenues are there, so many requirements are there. So don't worry, I think it is the most important issue, important resource rather to say for all industries. And that will be very, very useful. I don't think that they are demanding rather, more demanding for this subject in future.
These things should come in the policy and law of the government, and this should not be treated as a secondary or tertiary, just ticking the boxes, which is happening currently for this kind of area.
One question here, very clear.
I had a question to the industrial infrastructure part. So use of blueprint in the infrastructure and nature-based solution, what are the things that are being used right now in your companies? Are they incorporating this kind of structures?
See, the thing is that every company, they have an ESG goal that they will be carbon neutral or something in another 20 years, 30 years. So they have taken some steps, recycling of things or measuring something. What is the waste we are generating, how much we are recycling. Other than that, there are certain products which people are trying to incorporate in the recycling. One is used with recycled material, like you keep the plastic in the roads or the recycled tire. Then we have structural steel, which is low carbon steel are available. Low carbon, not the carbon content, but carbon footprint point of view. But they are in our country currently is the very costly product. So obviously at some point these things will come and will help us quite.
Even Indian Green Building Council, there are some standards. What are the green building standards? Even practices or all buildings are pattern of that building. So what that is a business requirement. So how this pattern method means how you consume your energy, mineral consumption will reduce your consumption, then how you are doing waste management. An IT company doesn't mean that they are not having waste. Huge waste is generated, food waste, garden waste. So how they are recycling it at 100% recycling. So by using the biogas technology, vermicomposting, biocomposting, in terms of building the green material, you are utilizing the maximum use of daylight, right? So in this way, this all green infrastructure are included and getting very high demand. Every industry is trying to be as possible, maybe silver rated or maybe gold rated or maybe platinum rated. So I mean, green infrastructure have a very, very huge demand in future, and that still is there.
So these standards started in the US, then it came to India, IGBC, again called LEED, now it's called GREEN.
Yes.
So different standards. But, and there are two parts of it. One is during the construction phase, during the operating phase. So overall, it has to reach certain level of scoring or number based on your how much you are returning back to the climate and how much you are benefiting there. So that is
one of the interesting story I would tell about this. Because USGBC, United Nations Green Energy Council. So TCS have one building, first building they have done. And it was so systematically done, they are that based on their evaluation, they have written the entire fees to them. That beautifully they have managed all whatever constructions were given, systematically managed, and they were so impressed that they have written the fees. So what I feel that there are great demand for green infrastructure, blue infrastructure, what you are talking about. That's all very important. So this is the current trend rather to say. And you can know about the standards. What are the IGBC standard? What is UGBC standard? So that sort of requirements you know, and accordingly you can provide. So that is very good.
Many case studies available, like in the Naik, IIT is a big house. All their businesses are highly regulated.
Can I just make a comment on that question?
And with that we will end.
Yeah. That was with respect to the job opportunities part. Now I belong to a corporate, so I have to say that the captive experts in our group, as far as this area is concerned, is not very high at this point of time, and we rely quite heavily on the external consultancy firms. So especially as a growing industry, as a growing area, I think the external consultancy firms would be the initial pool who would be focusing on this, and later it will get picked up by the industry. That's what I believe, and it has been happening to some extent in our industry also. So that's what I thought I'll share that with you. Thank you.
I'll add to your question. So I think you were asking blue green infrastructure in context of its impact on the microclimate and resilience. See, people do try to incorporate blue green infrastructure because of the prescriptive benefits. In the absence of climate science layer on top of it, nobody knows that what is the real impact it is bringing. In fact, we are also at a loss to understand that, apart from some Landsat studies here and there, we see that this is good or that is, but that's not the real impact. The real impact can be much more than the prescriptive benefits that are given by incorporating blue green infrastructure. And I think this level of science is very important.
See, on that note, let's thank all the panelists. So before we end, let me also thank all the volunteers who made this happen, and in particular, I want to mention Shiva. Everything that went right with this event is because of yeah, Shiva insists we take a group photo, so let's take it. Yeah, we can together.